What if the stories told by ancient civilizations weren't just myths, but hidden blueprints of the universe itself? Think about it. Thousands of years ago, long before telescopes or particle accelerators, cultures across the globe described the birth of reality in eerily similar ways. They spoke of cosmic serpents, primordial waters, and worlds woven from vibration ideas that sound strangely familiar to anyone who's studied modern physics. Today, we're diving deep into the 42 most astonishing parallels between these ancient creation myths and the mind-bending concepts of string theory. It's a journey that will challenge everything you thought you knew about history, science, and the very fabric of existence. Picture this: an Egyptian priest carving hieroglyphs about a serpent uncoiling to form the cosmos, while halfway across the world, Hindu sages wrote of a universe humming with sacred sound. Fast forward to the 20th century, and physicists discover that reality might literally be built from tiny, vibrating strings, energy threads dancing in dimensions beyond our perception. The similarities are too precise to ignore. How could civilizations separated by oceans and millennia describe the same cosmic truths without sharing a single equation? Were they tapping into some profound intuition about reality? Or is there something even more extraordinary at play? This isn't just about spotting vague resemblances, it's about uncovering a pattern so consistent it reshapes our understanding of human knowledge. From the Mayan Popol Vuh to the Aboriginal Dreamtime, these stories don't just echo string theory, they mirror its most radical implications. The idea that space and time are woven together like a tapestry, that multiple dimensions exist beyond our perception, even the notion that reality is, at its core, a symphony of vibration. Our ancestors might have known it all along. So buckle up. Over the next 42 revelations, you'll witness how myth and science converge in ways that defy coincidence, leaving you with one burning question. Did ancient cultures somehow glimpse the secrets of the universe long before modern science caught up? The answers ahead will astonish you. One of the most striking patterns across ancient creation stories is the recurring image of a cosmic egg, a perfect, self-contained vessel holding the entire universe within its shell. The Hindu Rigveda speaks of the golden Brahmanda egg floating in the void before splitting open to release all of creation. The ancient Egyptians told of the egg laid by the celestial goose on the primordial mound, while Finnish mythology describes the world forming from the shattered pieces of a divine egg. Even in China, the cosmic egg appears in Taoist texts as the primordial chaos containing yin and yang. What's astonishing is how these stories, separated by thousands of miles and years, all land on the same metaphor, a single point of infinite potential waiting to unfurl. Now fast forward to modern cosmology. String theorists describe the birth of our universe as a singularity, an infinitely dense, hot point that expanded outward in what we now call the Big Bang. The mathematics suggest that before this moment, space and time as we know them didn't even exist. Just like those ancient eggs, our entire observable universe may have emerged from something impossibly small and self-contained. The resemblance goes deeper. Both the cosmic egg myths and string theory propose that creation wasn't a random accident, but the unfolding of something already latent, waiting for the right conditions to burst forth. But here's where it gets truly mind-bending. Some versions of these myths don't just describe the egg cracking open, they describe it vibrating. The Orphic tradition from ancient Greece tells of the cosmic egg resonating with a sound that set existence into motion. Meanwhile, string theory posits that the fundamental building blocks of reality aren't particles, but tiny, vibrating strings whose oscillations determine everything from gravity to light. Could the ancients have been describing the same phenomenon in poetic terms, whether it's the hum of sacred syllables in Hindu tradition or the Aboriginal songlines that literally sing the world into being? These cultures seem to grasp something modern physics is only now verifying. That vibration isn't just part of reality. It might be reality's very foundation. The cosmic egg symbolism isn't just a quaint coincidence. It's a testament to how deeply humanity has always yearned to understand where we came from, and how often those intuitions align with truths we're still uncovering today. Whether through myth or mathematics, we keep returning to the same profound idea that everything we know, from the stars to our own breath, began as something impossibly small, waiting to unfold. The serpent slithers through creation myths across continents, not as a villain, but as the primal chaos from which order emerges. In ancient Egypt, the monstrous Apep coiled through the underworld, threatening to swallow the sun and plunge creation back into nothingness. Yet this chaos wasn't purely destructive. It was the necessary counterbalance to Maat, the principle of cosmic order. Half a world away, the Aztecs worshipped Quetzalcoatl, the feathered serpent whose very movements stirred the formless void into mountains and rivers. Even the biblical Leviathan, though later demonized, originally symbolized the untamed waters of pre-creation. These cultures weren't just spinning tales. They were mapping the universe's fundamental tension between chaos and structure, a dance modern physics now quantifies. String theory reveals something astonishing. What we perceive as stable reality is actually a sea of quantum fluctuations. At scales smaller than atoms, particles flicker in and out of existence, governed by Heisenberg's uncertainty principle. Empty space isn't empty at all. It's a frothing ocean of virtual particles, where energy borrows itself into existence only to vanish moments later. This isn't just background noise. These fluctuations shape everything. They determine why stars form unevenly, why galaxies cluster in vast cosmic webs, even why life had the uneven terrain needed to evolve. The serpent of chaos, it turns out, wasn't just a metaphor. It's the quantum foam underpinning reality itself. What's truly uncanny is how these ancient myths anticipated quantum behavior. The Egyptians depicted Apep not as a static monster, but as an ever-present force that Ra's solar bark had to navigate nightly, mirroring how quantum systems constantly balance disorder and coherence. The Norse Jörmungandr, encircling Midgard with its tail in its mouth, echoes the self-contained, cyclical nature of quantum fields. Even the Aboriginal rainbow serpent doesn't merely create landforms. It continuously reshapes them through its movements, much like quantum fluctuations mold space-time at every instant. These parallels go beyond superficial resemblance. They suggest a visceral understanding that order doesn't erase chaos, but harnesses it. Modern physics confirms this intuition. The Higgs field, which gives particles mass, emerged from symmetry, breaking a moment when perfect uniformity gave way to fruitful instability. Black holes, those ultimate destroyers, also birth new galactic structures through their energetic jets. Just as Apep's resistance made Ra's victory meaningful, quantum uncertainty makes the universe's structure possible. Without that underlying chaos, stars wouldn't ignite, atoms wouldn't bond, and life couldn't emerge. The ancients may not have had equations, but their myths encoded a profound truth. Creation isn't a one-time event, but an ongoing negotiation between form and flux. This revelation flips our perspective on these stories. When the Babylonian Tiamat's body became the fabric of the world, or when the Hindu Ananta-Shesha supported Vishnu on its endless coils, they weren't just explaining origins. They were describing cosmology in motion. The serpent isn't merely a symbol of destruction, but of potential. It's the writhing, creative instability that lets universes unfold. String theory's vibrating strings exist in a similar dance where stability emerges from dynamic tension. Perhaps these myths weren't primitive guesses, but intuitive insights into a truth we're still unraveling. That chaos isn't the enemy of order, but its crucible. High above the realm of gods and mortals, the Norse envisioned Yggdrasil, an immense ash tree whose roots drank from 3 sacred wells, whose branches cradled the 9 worlds, and whose trunk pulsed with the very breath of existence. At the same time, in ancient India, sages described the Ashvattha tree, its roots in the heavens and branches stretching downward to nourish the earth. These weren't just poetic images, they were blueprints of a universe far more connected than anyone could have imagined. Today, astronomers mapping the cosmos have stumbled upon something eerily familiar. A sprawling, invisible architecture they call the cosmic web, a labyrinth of galaxies threaded together by filaments of dark matter stretching across billions of light years. The resemblance between these ancient trees and modern cosmology's grandest structure isn't just striking, it's downright uncanny. Consider how these myths described their cosmic trees. Yggdrasil wasn't a passive backdrop, it was alive, its roots tapping into realms of wisdom, destiny, and primal energy. The Ashvattha tree in the Upanishads was similarly dynamic, its leaves whispering the Vedas themselves. Now compare that to the cosmic web. Dark matter filaments aren't static scaffolding but flowing rivers of gravity, channeling galaxies into clusters and superclusters like leaves clustering on branches. The web's nodes where filaments intersect mirror the Norse wells of fate and memory, gathering matter into dense, vibrant hubs where stars and civilizations bloom. Both visions share a profound insight. The universe isn't a random scatter of objects, but a living network where every part communicates with the whole. What's even more remarkable is how these myths accounted for the unseen. Norse legends spoke of creatures gnawing at Yggdrasil's roots, forces of decay balancing creation. Hinduism's Ashvattha was nourished by an invisible sap called soma, the elixir of immortality. Modern science reveals an equally hidden framework. Dark matter, which makes up 85% of the universe's mass, remains invisible to telescopes. Yet its gravitational pull sculpts the cosmic web, just as Yggdrasil's hidden roots anchored the Norse cosmos. Both systems acknowledge that the most powerful forces shaping reality are the ones we can't see directly, only perceive through their effects. The parallels grow deeper when you examine function. The world tree wasn't just a map, it was a conduit. Odin hung himself from Yggdrasil to gain forbidden knowledge, while Hindu ascetics meditated beneath the Ashvattha to attain enlightenment. Similarly, the cosmic web isn't just structure, it's a highway for energy and information. Galaxies slide along dark matter filaments like beads on a string, exchanging gas and stars. Black holes at galactic centers, modern analogues to Yggdrasil's wisdom, giving wells funnel energy across vast distances. These myths intuited what astrophysics confirms. The universe thrives on connection, with pathways that transmit not just matter, but the potential for transformation. Perhaps the most breathtaking similarity lies in scale. Both Yggdrasil and the Ashvattha were described as infinite, their branches and roots extending beyond comprehension. The cosmic web, too, defies human imagination. A single filament can stretch 500 million light-years, with galaxies strung along it like dewdrops on a spider's thread. And just as the world tree linked realms from the icy underworld to the fiery heavens, the cosmic web binds dwarf galaxies to colossal superclusters in a single, unbroken hierarchy. The ancients may not have known about galaxy formation, but their myths captured the universe's fractal nature, the way patterns repeat from the smallest twig to the grandest bough. This isn't mere metaphor. Recent simulations of the cosmic web, with its delicate filaments and dense nodes, look unsettlingly like the gnarled branches of an ancient tree. When researchers traced the flow of hydrogen gas through the universe, they found it moving along these dark matter channels like sap through xylem. Even the gaps, the voids between filaments, mirror the hollows described in Norse myth where dragons coiled. The more we map the large-scale structure of the universe, the more it resembles those age-old visions of a tree whose fruit was every star, every world, every conscious being. So why would cultures separated by millennia and geography converge on this image? Maybe because trees, in their branching complexity, model a fundamental truth about reality. That growth requires both divergence and connection. A tree's limbs split outward, yet all draw from the same trunk. The cosmic web, too, shows how the universe diversifies galaxies evolving along isolated paths, while remaining bound by gravity's invisible threads. These myths didn't just guess the universe's shape, they grasped its essence. In a cosmos where dark matter roots connect swirling galaxies like Yggdrasil's roots bound the 9 worlds, perhaps the old seers were closer to the truth than we ever dared believe. Long before physicists coined the term multiverse, Hindu sages were describing infinite worlds blooming like lotus petals from the navel of Vishnu. The Puranas detail countless universes, each with its own creator, sustainer, and destroyer, parallel realms where time flows differently and physical laws vary. Meanwhile, halfway across the ancient world, Norse mythology spoke of Yggdrasil's 9 interwoven worlds, while Buddhist texts envisioned a 1,000-million-fold world system stretching endlessly through space. These weren't vague poetic flourishes, they were meticulously detailed cosmologies that eerily anticipate modern string theory's most radical proposition, that our universe is just one bubble in an endless cosmic foam. String theory's mathematics suggest something extraordinary, that the Big Bang may not have been a unique event, but one eruption among infinite others. According to the brain multiverse concept, our 3-dimensional universe could be a membrane floating in higher dimensional space, occasionally colliding with others to birth new cosmic cycles. Some versions of the theory propose up to 10 to the power of 500 possible universes, each with different fundamental constants. Now compare that to the Bhagavata Purana's description of universes as numerous as specks of dust in a sunbeam, each with its own Brahma governing a unique lifespan. The precision of this parallel chills the spine. How could a text dating back over 2,000 years articulate what cutting-edge physics now struggles to model? The similarities grow even stranger when examining how these ancient accounts describe interaction between worlds. Hindu texts speak of lokas, realms existing simultaneously yet separated by vibrational frequency, accessible only to enlightened beings. String theory posits that other universes might occupy the same space as ours but vibrate at different harmonics, making them imperceptible. The Mayan Popol Vuh describes gods moving between worlds through serpent ropes, while modern physics theorizes about Einstein-Rosen bridges wormholes threading through folded spacetime. Even the Aboriginal concept of the dream time, where ancestors traverse alternate planes of existence, mirrors the bulk of string theory, the higher dimensional space where parallel universes float like pages in a vast cosmic book. Perhaps most remarkable is how these myths account for the diversity of possible realities. The Hindu cosmology describes universes where time runs backward, where gravity behaves erratically, even realms made purely of sound or light. String theory's landscape of possible universes includes those with stronger nuclear forces where stars burn out in millennia, or weaker electromagnetism where atoms never bond to form molecules. Both systems recognize that the laws we consider immutable might just be local bylaws in a grander cosmic democracy. The Aztecs took this further with their 5 suns doctrine, 5 successive universes, each destroyed and reborn under different elemental rules, echoing the string theory notion of vacuum decay, where our universe could transition into a new state with rewritten physics at any moment. What unites these ancient multiverse theories isn't just their scope but their purpose. They weren't merely speculative, they served as spiritual roadmaps. The Buddhist 3,000-fold world system illustrated karma's infinite permutations, while Hindu texts used the multiverse to explain divine play. Modern science arrives at similar conclusions from another angle. The anthropic principle suggests our universe's fine-tuned laws may reflect selection bias. We can only exist in a universe that permits life. The ancients and today's physicists converge on a humbling truth that our reality, however vast, might be just one thread in a tapestry too immense to fully comprehend. This convergence raises profound questions about the nature of human knowledge. Did these cultures access insights through deep meditation or visionary states that modern science is only now rediscovering through mathematics? Or is the multiverse such an intrinsic pattern of existence that it surfaces independently across epochs and disciplines? Whether through sacred texts or superstring equations, humanity keeps arriving at the same breathtaking possibility that every choice branches into new worlds, every moment echoes across dimensions, and the cosmos is far stranger and more abundant than our senses dare suggest. In the stillness of a temple courtyard, a bronze statue of Shiva Nataraja stands frozen mid-motion, 1 foot crushing ignorance, 4 arms outstretched, flames circling his form. This isn't just art, it's a 2,000-year-old model of the universe's restless energy. Hindu texts describe Shiva's dance as the source of all creation and destruction, a cycle where worlds emerge from his drumbeat and dissolve into his fire. Now fast forward to the 19th century when physicists coined the term entropy to describe a startling truth. Energy never vanishes but constantly degrades into chaos. The parallels between these two visions, one mystical, one mathematical, reveal a shared insight about reality's irreducible dynamism that transcends time and culture. Shiva's dance isn't random movement, it's a precise choreography of cosmic principles. His upper right hand holds the Damaru drum whose rhythm births atoms and galaxies, while his upper left hand clutches the flame that reduces them to ash. This mirrors thermodynamics' first law: energy cannot be created or destroyed, only transformed, and its second law, which dictates that all systems inevitably trend toward disorder. The ancients didn't have equations for heat death or quantum fluctuations, but they grasped the essential truth. The universe isn't a static artifact, but a performance where every particle pirouettes between form and dissolution. Modern physics amplifies this insight. At the quantum level, particles blink in and out of existence like Shiva's flickering flames. Black holes devour stars only to radiate energy back into space through Hawking radiation, a celestial echo of destruction feeding creation. Even the arrow of time, which thermodynamics ties to increasing entropy, finds its counterpart in Shiva's cyclical dance. Hindu cosmology speaks of Mahayugas, vast epochs where universes are born, mature, decay, and renew, much like entropy's grand narrative where energy disperses until it's ripe for reorganization. The brilliance of Shiva's symbolism lies in its embrace of paradox. His dance occurs simultaneously within a ring of fire, pralaya, the great dissolution, and atop a demon, apasmara, representing ignorance of reality's true nature. This duality mirrors thermodynamics' own contradictions. Energy is conserved yet constantly degrading. Time's arrow is irreversible, yet quantum processes are time-symmetric. Just as Shiva balances creation and destruction in one fluid motion, the universe sustains itself through tension between opposing forces, fusion and fission in stars, anabolism and catabolism in living cells. Perhaps most striking is how both systems account for regeneration. Shiva's flames don't signify absolute annihilation, but purification, clearing space for new cycles. Similarly, entropy isn't just decay, it's the universe's way of recycling energy. Stars die in supernova, scattering elements that become new solar systems. Forests burn to nourish the next generation of growth. The Navajo understood this principle in their own cosmology, where disorder Hajarogi and harmony Hajoa exist in necessary balance. These traditions all point to the same profound realization. Destruction isn't an end, but a phase in perpetual transformation. Today's physicists might use different language, but their conclusions resonate with startling familiarity. When string theorists describe the universe as a hologram where information is never lost, just scrambled at black hole horizons, they echo Shiva's promise that nothing truly vanishes, only changes form. The discovery of thermodynamic fluctuations in the cosmic microwave background, primordial whispers of the universe's first uneven energy distribution, mirrors the Hindu concept of Shiva's dance, introducing purposeful asymmetry into the void. Even the quest for a grand unified theory, seeking to reconcile quantum mechanics with gravity, parallels Shiva's role as the unifier of opposites, transcendent yet immanent, destroyer yet benefactor. This convergence raises a tantalizing question. Did ancient seers access intuitive knowledge about reality's fabric through meditative states or visionary experiences? Or does the human mind, when contemplating existence deeply enough, inevitably arrive at certain universal patterns? Whether through mythology or mathematics, we keep rediscovering that stability is an illusion, that the cosmos thrives on rhythmic upheaval. Shiva's dance and the laws of thermodynamics aren't just compatible ideas. They're twin visions of a truth too vast for any single discipline to contain. As we peer deeper into quantum foam or galactic evolution, we're not just doing science, we're joining a dance that began long before equations existed, one whose steps are written into the fabric of space and time. Walk through the Parthenon's ruins today, and you'll sense something beyond its crumbling marble, a harmony so precise it feels almost musical. The ancient Greeks didn't just build temples, they encoded the language of the cosmos into stone. Look closely, and you'll find the Fibonacci ratio governing everything from column spacing to pediment proportions, a spiral of 1.618 echoing through every architrave. This same ratio appears in seashells, galaxy arms, even the branching of human veins. But here's what chills the spine. Modern string theorists discover identical geometry in Calabi-Yau manifolds, the six-dimensional shapes they believe may house the universe's hidden dimensions. Did ancient architects stumble upon sacred geometry by accident, or were they privy to truths we're only now rediscovering? The Fibonacci sequence isn't just a math trick, it's nature's signature. Start with 0 and 1, add the last two numbers to get the next, and soon you're spiraling through a sequence found in sunflower seed patterns, hurricane formations, even the stock market's ebb and flow. But when builders from Egypt to Cambodia embedded this ratio into sacred sites, they weren't just mimicking beauty. The Great Pyramid's height to base ratio mirrors Fibonacci. Angkor Wat's lotus towers ascend in Fibonacci tiers. Even Gothic cathedrals like Chartres encode the sequence in Rowe's window tracery. These weren't aesthetic choices, they were acts of cosmological alignment, threading human worship into the universe's fundamental fabric. Now zoom into string theory's most enigmatic structures, Calabi-Yau manifolds. These twisted, six-dimensional shapes describe how strings might vibrate through hidden dimensions. When mathematicians model them, Fibonacci ratios surface repeatedly in their topology, like cosmic fingerprints. The same spiral governing temple pillars also dictates how energy might fold through higher dimensional space. It's as if the ancients intuited what equations now confirm. Certain geometric relationships aren't just pleasing, they're universal constants, appearing from the quantum scale to galactic superclusters. The eerie precision raises provocative questions. Consider the Hindu temple of Brihadiswara, whose tower's height to width ratio matches Fibonacci to 4 decimal places, a feat requiring knowledge of irrational numbers centuries before Western mathematics formalized them. Or the fact that Fibonacci himself learned the sequence from Indian mathematicians, who'd linked it to cosmic creation myths long before. This wasn't isolated genius, it was a global tradition recognizing geometry as divinity made visible. Even Plato called these ratios the bones of the universe, while string theorists now describe Calabi-Yau shapes as the alphabet of reality's deepest layer. Perhaps most startling is how these architectural codes mirror string theory's audacious claim that the universe has a preferred geometry. Just as temples oriented doorways to solstice sunbeams, string theory suggests the cosmos chooses configurations where energy flows most efficiently, often Fibonacci-aligned. The Parthenon's columns channel stress along logarithmic curves identical to those in superconducting materials, while Calabi-Yau manifolds optimize vibrational stability through similar curvature. Both systems point to a profound truth. The universe isn't just built with math, it is math, a living equation where form and function merge. This convergence of ancient art and cutting-edge physics hints at something transcendent. When a 12th century mason carved Fibonacci spirals into a cathedral's labyrinth, or when a string theorist scribbles equations describing multidimensional resonance, they're speaking the same silent language, one that predates both science and religion. The temples still standing today aren't just relics, they're resonant chambers humming with a pattern so deep it stitches together quarks and quasars. Whether through chisel or supercomputer, humanity keeps tracing the same sacred shapes, compelled by the unshakable sense that beauty and truth are woven from the same golden thread. The ancient Greeks gazed at the world and saw 4 irreducible elements: earth, air, fire, and water, dancing in an eternal cycle of transformation. These weren't just poetic classifications, they were an attempt to decode reality's blueprint. Now, fast forward to the 20th century, when physicists identified the 4 fundamental forces governing everything from atoms to galaxies. The parallels between these frameworks, separated by millennia, are too precise to dismiss as coincidence. Gravity's invisible pull mirrors Earth's grounding force. Electromagnetism crackles with the same energy as Zeus's lightning, while the nuclear forces, strong and weak, echo fire's transformative power and water's fluid adaptability. It's as if the ancients mapped the cosmos with intuition long before microscopes or telescopes could confirm their vision. Take gravity first. The Greeks associated Earth with stability, weight, and the downward pull toward the center, qualities eerily reminiscent of Einstein's curved spacetime. Just as Earth forms the foundation of the material world, gravity structures the universe itself, sculpting planets and bending light. Then consider air, which ancient thinkers linked to breathe, expansion, and invisible currents. Modern electromagnetism behaves similarly, an unseen field carrying radio waves through the void, binding atoms into molecules, even animating our nervous systems. The Greeks may not have known about photons, but their concept of air as a medium for connection and communication aligns perfectly with electromagnetism's role as nature's messenger. Fire's correlation with the strong nuclear force is even more striking. In myth, fire was both creator and destroyer, forging swords in Hephaestus's forge while reducing cities to ash. Similarly, the strong force welds protons and neutrons together in atomic nuclei, releasing the stellar fire of fusion, yet its sudden release in nuclear fission can unleash apocalyptic energy. Even fire's dual nature, heat as life-giving warmth or consuming flame, mirrors how the strong force balances between binding and repulsion. Meanwhile, water's fluidity and changeability find their counterpart in the weak nuclear force, which enables particles to transform identities through radioactive decay. Like rivers carving new paths, the weak force reshapes matter itself, allowing stars to forge heavy elements and life to emerge. What's truly remarkable is how these elemental forces interact. The Greeks envisioned earth and water as complementary opposites, solidity and fluidity in tension. Modern physics reveals a similar dance. Gravity pulls matter inward while electromagnetism pushes outward, their balance determining whether a star collapses or shines. Fire and air, too, find their parallels in the strong force's binding power versus the weak force's tendency to destabilize. These aren't vague metaphors but structural echoes, ancient minds discerning the universe's push and pull dynamics through observation and intuition. The connections go deeper than mere categorization. Empedocles, the philosopher who formalized the four-element theory, described them as governed by love and strife, attraction and repulsion. Today, physicists speak of force carriers, gravitons, photons, gluons. Both frameworks recognize that existence hinges on relationship, on particles and elements forever seeking equilibrium. Even the gaps in ancient knowledge are revealing. The Greeks couldn't have known about quantum fields, yet their elements align with the four forces: hierarchical strength, gravity weakest, then weak nuclear, electromagnetism, and finally the mighty strong force. Just as earth yields to water, then air, then all-consuming fire. This convergence raises a tantalizing possibility that the four elements weren't primitive guesses, but phenomenological insights into how reality behaves at human scales. When a potter molds clay earth, boils water, fans flames, or feels the wind, they're interacting with localized expressions of universal forces. The Greeks may have lacked particle accelerators, but their observations distilled deep truths about energy's manifestations. Modern physics hasn't disproven their model, it's revealed the underlying mechanisms. After all, what is Earth if not the emergent property of gravity and nuclear forces binding atoms into matter? What is fire but electromagnetism's visible dance? Perhaps the most profound parallel lies in unity. Just as the Greeks believed the elements combine to create all substances, modern physics seeks a unified theory where the four forces merge into one primordial interaction. The ancients imagined a primal chaos where elements were undifferentiated, a concept mirroring the singularity before the Big Bang, when forces were indistinguishable. Whether through myth or mathematics, humanity keeps circling the same revelation, that beneath apparent complexity, the universe operates through elegant, interconnected principles. The four elements may not be literal, but as symbols of nature's fundamental dialogues, they were closer to the truth than anyone could have imagined. At the heart of countless myths lies a spine of the cosmos, a towering axis bridging the earthly and divine. The Norse called it Yggdrasil, the world tree whose roots plunged into underworld springs while its branches cradled Asgard. Siberian shamans spoke of the iron pillar piercing celestial spheres, while the ancient Mesopotamians envisioned a ziggurat stairway where gods descended to earth. These weren't just fanciful images, they were attempts to map a profound truth about the universe's architecture, one that finds startling resonance in modern astrophysics' most enigmatic phenomenon, black holes. Both concepts orbit a single terrifying idea, that at the center of existence lies a point of infinite density, a gateway where the fabric of reality twists beyond recognition. Consider how these myths describe their cosmic axis. The axis Mundi was never just a physical pillar or tree, it was a conduit. The Aztecs' Teotihuacan pyramids aligned so precisely that on certain days, shadows formed what appeared to be a serpent slithering down to earth, mimicking Quetzalcoatl's descent. Aboriginal Australians' sacred Uluru was believed to connect the dreamtime to the present through vibrational songlines. These traditions understood the axis as both anchor and portal, a place where dimensions blurred. Now compare that to a black hole's event horizon, the point where space-time curves so severely that light itself cannot escape, where matter compresses into a singularity of infinite density. The resemblance is chilling. Both systems describe a threshold where ordinary laws collapse and transformation becomes possible. The parallels grow even more precise when examining function. Ancient texts often depict the axis Mundi as a place of trial and rebirth. In Siberian shamanism, initiates climbed the world tree's notches, facing spiritual tests at each level before gaining wisdom. Similarly, black holes aren't just destroyers, they're cosmic recyclers. Matter falling toward the singularity doesn't simply vanish. According to Hawking radiation, its information gets scrambled and re-emitted over eons. Some theories even suggest black holes could birth new universes in their cores, their singularities becoming big bangs for other realities. The axis Mundi's role as a transformer, where seekers shed their old selves to emerge renewed, mirrors the alchemy happening at the universe's most extreme edges. What's truly astonishing is how these myths anticipated black holes' geometry. The Hindu Skambha Sukta describes the cosmic pillar as having neither top nor bottom, existing simultaneously across all planes, a description eerily similar to a singularity's timeless, spaceless nature. The Mayan world tree was often depicted with roots mirroring its branches, suggesting a symmetry that modern physicists observe in black hole math. The equations work equally well whether time flows forward or backward near the singularity. Even the Norse description of Yggdrasil's roots tapping three separate wells, one boiling, one icy, one filled with wisdom, uncannily parallels the three possible fates of matter approaching a black hole: incineration in the accretion disk, freezing at the event horizon due to time dilation, or transformation into pure information. This isn't just metaphorical coincidence. Recent simulations of black holes reveal structures called plasma filaments, magnetized tendrils of superheated gas spiraling into the void, looking unsettlingly like the roots and branches of Yggdrasil in ancient carvings. The Milky Way's supermassive black hole, Sagittarius, a star, even exhibits a puzzling symmetry. Its relativistic jets shoot perpendicular to the galactic plane, mirroring how axis Mundi myths describe the cosmic pillar as aligning with the celestial poles. The more we study these gravitational monsters, the more they resemble the mythic axes, both serving as structural supports for their respective cosmoses, both warping the very fabric of existence around them. Perhaps the most profound parallel lies in their dual nature. The axis Mundi was always paradoxical, simultaneously the world's most stable anchor and its most volatile threshold. Black holes embody the same contradiction. Their immense gravity creates stable orbits for stars like our solar systems dance around Sagittarius, a star, while their cores host physics' most violent transformations. The Babylonian Etemenanki ziggurat was said to be the bond between heaven and earth, just as black holes mathematically link quantum mechanics with general relativity. Both concepts suggest that ultimate truth lies not in separation, but in the places or points where opposing forces converge. This convergence of myth and astrophysics raises a humbling possibility that humanity's oldest stories weren't mere superstition, but intuitive maps of cosmic architecture. When a Tibetan monk visualizes the axis of Mount Meru during meditation, or when a physicist calculates the spin of a Kerr black hole, they're grappling with the same fundamental pattern, one where the universe organizes itself around centers of unimaginable power. Whether through mantra or mathematics, we keep returning to the vision of a spine running through creation, reminding us that even in the vastness of space, everything is connected through invisible, irresistible threads. From the ashes of its own destruction, the phoenix rises anew, a symbol so universal it appears in Egyptian, Greek, Chinese, and Native American traditions with uncanny consistency. These cultures, separated by continents and centuries, all envisioned a radiant bird that cyclically immolates itself only to emerge reborn from the flames. What's astonishing isn't just the similarity of these stories, but how precisely they mirror one of cosmology's most debated theories, the idea that our universe might collapse in a big crunch, only to explode outward again in an endless cycle of cosmic rebirth. The phoenix wasn't just a myth, it was an intuitive blueprint for the universe's potential rhythm, encoded in feathers and fire long before physicists put it in equations. Consider how these myths describe the phoenix's transformation. In ancient Egypt, the Bennu bird prototype of the Greek phoenix was said to burst into flames at the end of its 500-year lifespan, its ashes coalescing into an egg that birthed its successor. Chinese Feng Huang legends speak of a solar bird that dissolves into pure energy before reincarnating, while the Native American thunderbird vanishes in storms only to reappear with the next lightning strike. These aren't random tales of resurrection, they're meticulous accounts of a process where destruction isn't an end, but a necessary phase of renewal. Now compare that to the Big Crunch hypothesis. As the universe expands, gravity might eventually reverse its motion, pulling all matter back into a singularity so dense it triggers another Big Bang. Parallels are too exact to ignore, a celestial phoenix cycling through cosmic-scale combustion and rebirth. Modern physics amplifies these ancient insights with startling clarity. The cyclic model of the universe, championed by theorists like Paul Steinhardt, proposes that the Big Bang wasn't a one-time event, but the latest in an infinite series. Each cycle begins with rapid expansion, slows under gravity's pull, then collapses into a big crunch that becomes the seed for the next universe. The mathematics reveal something profound. Just as the phoenix's ashes contain the blueprint for its new form, a collapsing universe might preserve quantum information in the singularity, ensuring the next cycle inherits certain patterns from its predecessor. This mirrors the Aztec belief that each sun epoch was destroyed by catastrophe, only for a new sun to rise with echoes of the old world's essence. The resemblance grows even deeper when examining time's role in these narratives. Hindu cosmology speaks of kalpas, days of Brahma lasting 4.32 billion years, ending in dissolution pralaya before the next cycle begins. Similarly, cyclic universe models calculate each eon as lasting roughly 1 trillion years. Both systems recognize that cosmic time isn't linear, but a wheel turning through creation and dissolution. Even the phoenix's famous tears, said to heal wounds in some traditions, find a parallel in dark energy, the mysterious force accelerating expansion today, but which cyclic models suggest could transform into a contracting force over astronomical timescales, healing the universe's dispersion. What's truly breathtaking is how these myths anticipated modern dilemmas. The phoenix's flames were often described as purifying, burning away the old to make way for the new, a concept mirroring how each big crunch would erase cosmic structures like galaxies, resetting conditions for fresh complexity to emerge. The Egyptian Bennu was associated with the Nile's floods, cyclically wiping the land clean for new fertility, just as a collapsing universe would reset entropy, allowing information to reorganize. These stories didn't just guess at cosmic renewal, they intuited the delicate balance required for it, the precise calibration where destruction feeds creation rather than annihilating it. This convergence raises a profound question. Did ancient cultures access insights about cosmological cycles through visionary states or shamanic journeys? Or does the human mind, when observing nature's cycles, seasons turning, civilizations rising and falling, inevitably extrapolate to universal scales? Whether through myth or mathematics, we keep rediscovering that existence may not be a one-act drama, but an eternal return. The phoenix's flames and the big crunch's singularity both whisper the same secret. Endings are illusions. What we call death might just be the universe taking a breath before beginning anew. Deep in the red earth of Australia, Aboriginal elders still sing the stories of the rainbow serpent, a being so vast its coils carved riverbeds, so radiant its scales shimmer with every color of the land. But this isn't just a tale about a snake, it's a profound meditation on light's transformative power. The serpent doesn't merely move through the landscape, it becomes the landscape, its iridescent body mirroring the way sunlight fractures into hues after rain. Half a world away, string theorists grapple with a strikingly similar concept, that all light, from the softest starlight to the fiercest gamma rays, arises from vibrations along tiny cosmic strings. Both traditions, one ancient, one cutting edge, converge on the same breathtaking realization. Color isn't just something we see, it's the very language of creation. The rainbow serpent's brilliance lies in its duality. In Arnhem Land rock art, it's depicted with bands of ochre and white clay, symbolizing how it contains all colors yet transcends them. Dreamtime stories describe it emerging from waterholes, its prismatic scales refracting light into the first dawn. This mirrors how string theory explains light's spectrum. Each hue corresponds to a specific vibrational frequency along a string's length. Red light hums at a lower pitch, violet at a higher one. Just as the serpent's body shifts tones along its coils, the parallel goes deeper. Both systems recognize that these variations aren't arbitrary, but steps on a continuous ladder of energy. When Aboriginal custodians speak of the serpent singing the world into being, they're uncannily close to the string theorist's view that reality emerges from harmonics. Modern physics reveals something the ancients intuited. Light's spectrum is more than a visual phenomenon, it's a bridge between worlds. The visible rainbow spans wavelengths from 380 to 750 nanometers, but the electromagnetic spectrum extends infinitely beyond what human eyes perceive. Radio waves stretch longer than skyscrapers, while gamma rays vibrate smaller than atomic nuclei. The rainbow serpent myths anticipated this expansiveness, describing its tail dipping into unseen realms and its head touching the spirit world. Just as telescopes now reveal invisible frequencies, infrared galaxies, ultraviolet stellar nurseries, the serpent's lore acknowledged that most of reality exists beyond ordinary sight, accessible only through altered states or sacred knowledge. What's truly revelatory is how both traditions handle light's transformative power. In Aboriginal cosmology, the serpent doesn't just display colors, it uses them to shape reality. Certain song cycles describe it painting the land with specific hues to imbue plants with medicinal properties or animals with unique traits. String theory proposes a similar mechanism. When strings vibrate at distinct frequencies, they manifest as different particles, electrons, quarks, photons. Change the vibration and you change the building blocks of matter itself. This isn't just analogy, it's a shared recognition that vibration and color aren't superficial qualities, but the code underlying existence. The serpent scales and the string's harmonics both suggest that diversity arises from modulation of a single, universal theme. The most striking convergence lies in their treatment of unity. The rainbow serpent isn't multiple creatures, but one being whose spectrum expresses its wholeness. Similarly, string theory posits that all light from radio waves to X-rays stems from the same fundamental strings vibrating differently. Both systems dissolve artificial boundaries, revealing that apparent separations, colors, forces, even particles, are facets of a deeper continuity. When Navajo elders speak of walking in beauty, harmonizing with all hues of life, they echo what physicists call grand unification, the quest to reveal singular origins beneath nature's seeming fragmentation. This harmony of myth and math invites a radical shift in perspective. The next time you see a rainbow arcing across the sky, consider that you're not just observing refracted sunlight, but glimpsing the universe's deepest architecture. The same vibrational tapestry the rainbow serpent scales have symbolized for 60,000 years. Whether through ancestral stories or superstring equations, humanity keeps arriving at the same truth. That light, in all its varied frequencies, is both the brushstroke and the canvas of reality. In Hindu cosmology, the Acupara turtle swims endlessly through the cosmic ocean, its massive shell supporting the weight of entire continents. Across the Pacific, Iroquois and Lenape tribes tell of the earth resting on the back of great turtle, who dove into primordial waters to bring up mud that became our world. At first glance, these seem like simple creation tales until you consider Einstein's revelation that planets and stars aren't just floating in space, but bending spacetime itself with their gravity. The turtle's curved shell mirrors the very geometry of relativity, where mass warps the fabric of existence like a heavy ball resting on a trampoline. Einstein's equations describe gravity not as a force, but as the curvature of spacetime, an idea these myths visualized millennia earlier. When native storytellers spoke of continents resting on the turtle's back, they captured the essence of general relativity. That Earth doesn't simply hang in the void, but creates a depression in spacetime that holds everything in place. The Hindu version goes further. Acupara swims in the Keshara Sagara, an ocean of milk representing the quantum foam of potential existence. This eerily parallels modern theories where spacetime emerges from deeper, fluctuating energy fields. Both traditions intuited that the universe isn't built on rigid scaffolding, but on dynamic relationships between objects and the space they inhabit. The turtle's movements add another layer of insight. In many versions, the creature's slow paddling causes subtle shifts, earthquakes or tides, echoing how moving masses create gravitational waves in relativity. When LIGO detected ripples from colliding black holes in 2015, it confirmed Einstein's prediction that spacetime isn't static, but ripples like water. The cosmic turtle myths had already encoded this concept through metaphor, a living, mobile foundation whose adjustments transmit through the cosmic medium. Even the turtle's longevity, often described as eternal mirrors, spacetime's role as the enduring stage upon which cosmic events play out. Perhaps most remarkably, these stories anticipated the holographic principle. Some Hindu texts describe smaller turtles stacked beneath Acupara in an infinite regression, a fractal structure recalling how modern physics suggests our three-dimensional reality might be projected from information encoded on a two-dimensional surface. The turtle's shell, with its hexagonal plates, even resembles the pixel-like units of spacetime predicted by loop quantum gravity. Whether by chance or deep intuition, these ancient cultures sketched a universe far more fluid and interconnected than classical physics ever imagined. The cosmic turtle isn't just a charming myth, it's a masterclass in analogical thinking. By embodying spacetime's curvature in a creature both sturdy and adaptable, these traditions made relativity tangible long before tensor calculus existed. They remind us that sometimes truth arrives not through equations, but through stories that carry wisdom across generations, stories where a humble turtle swims through eternity, teaching us how the universe really works. The Ouroboros, an ancient symbol of a serpent devouring its own tail, has slithered through cultures from Egypt to Norse mythology, always carrying the same cryptic message: time is a loop, not a line. The Egyptians depicted it as Mehen, the coiled serpent protecting Ra's solar bark during its nightly journey through the underworld. The Norse called it Jörmungandr, the Midgard serpent whose body encircles the world, gripping its tail between its teeth. At first glance, these seem like poetic metaphors for eternity, but modern physics reveals something astonishing. These myths may have been describing closed time-like curves, the hypothetical loops in spacetime where an object could return to its own past. Einstein's equations allow for such bizarre geometries under extreme conditions near rotating black holes or cosmic strings, where spacetime twists so severely that the future bends back to meet the past. Picture a spaceship following one of these curves. It would spiral through space only to arrive at the same moment it departed, like the Ouroboros biting its own tail. The resemblance isn't superficial. Both systems grapple with the same paradox. The Ouroboros embodies the tension between destruction and renewal, a serpent consuming itself yet perpetuating its existence. Similarly, closed time-like curves defy classical causality, creating scenarios where an effect could precede its cause, yet somehow maintaining self-consistency. The parallels deepen when examining how these concepts handle paradox. The Gnostic text Pistis Sophia describes the Ouroboros as the world devourer that dissolves reality only to rebirth it, a cycle echoing physicist John Wheeler's participatory universe, where observers influence the past through quantum measurements. Even the serpent's circular form mirrors the Penrose diagrams physicists used to map how black holes warp time into loops. Both myth and math suggest that linear time might be an illusion, a local phenomenon in a universe where beginnings and endings are intertwined. What's truly mesmerizing is how these ancient symbols anticipated modern dilemmas. The Ouroboros often appears with its body divided into light and dark halves, representing opposing forces in balance, an uncanny foreshadowing of how closed time-like curves require negative energy to stabilize them, a concept mirrored in quantum field theory. The Aztec Zoocoatl, a fiery serpent that encircled the sun, was said to burn and renew time itself during the new fire ceremony, much like how traversing a time-like curve could reset a system's entropy. These cultures weren't just spinning tales, they were encoding profound insights about time's plasticity. Today, physicists like Kip Thorne explore whether such loops could exist without violating causality, just as alchemists once pondered the Ouroboros as a symbol of the primordial chaos underlying order. The serpent's endless cycle destruction feeding creation finds its counterpart in the chronology protection conjecture, where quantum effects might prevent time travel paradoxes by snipping rogue curves. Both visions, ancient and modern, converge on a truth that defies intuition. Time might not flow like a river, but pulse like a heartbeat, expanding and contracting in rhythms we're only beginning to discern. Whether etched on temple walls or scribbled in tensor equations, the Ouroboros endures as a reminder that reality's fabric is stranger than we imagine. Its coils whisper that every ending is a beginning in disguise, and that time itself might be the most cunning serpent of all, forever circling back to reveal what we missed the first time. When the ancient Greeks envisioned Zeus hurling his thunderbolt from Mount Olympus, they weren't just describing weather, they were mapping the chaotic, explosive essence of reality itself. That jagged bolt splitting the sky mirrors something far stranger happening at scales too small for the naked eye: the quantum leap, where electrons vanish from one orbit and reappear in another without crossing the space between. Both phenomena share a breathtaking signature energy released in sudden, unpredictable bursts, defying the smooth continuity we expect from nature. The thunderbolt wasn't just a weapon of the gods, it was an intuitive grasp of quantum behavior millennia before Planck or Heisenberg gave it equations. Consider how these myths describe lightning's origin. Zeus didn't draw his bolts from a forge or anvil. They emerged spontaneously from the ether, a realm of pure potential. Similarly, quantum leaps occur when an electron absorbs or emits a photon, jumping energy levels instantaneously. There's no gradual ascent or descent, just a disappearance and reappearance, as if the particle teleports. The Greeks may not have known about electron orbitals, but their depiction of lightning as a divine intervention rupturing the natural order with abrupt intensity uncannily mirrors how quantum mechanics upends classical physics. Even the thunderbolt's jagged path finds its parallel in Feynman diagrams, where particle interactions are depicted as sudden, zigzagging exchanges of energy. What's even more startling is how these stories capture quantum unpredictability. Greek poets wrote that no mortal could anticipate where Zeus's bolt would strike, just as quantum theory tells us we can only calculate probabilities for where an electron might reappear. The thunderbolt's capriciousness wasn't poetic license, it was an observation of nature's fundamental indeterminacy, later codified in Heisenberg's uncertainty principle. Norse mythology amplifies this insight. Thor's hammer Mjolnir didn't just throw lightning, it returned to his hand like a boomerang, embodying the wave-particle duality where energy behaves as both localized strike and spread out potential until measured. Parallels extend to how energy propagates. Lightning doesn't travel in a straight line, it forks and branches as ionized air creates multiple conductive paths. Quantum field theory reveals a similar branching at subatomic scales. Virtual particles constantly flicker into existence, creating a foam of possible interactions through which energy takes the path of least resistance. Hindu texts like the Vedas describe Indra's Vajra thunderbolt as having 100 joints. A poetic nod to the fractal-like path's energy follows when tunneling through quantum states. These myths didn't just anthropomorphize storms, they encoded observations about energy's nonlinear behavior. Perhaps the most profound similarity lies in transformation. Zeus's lightning wasn't merely destructive, it purified, fertilizing soil with nitrogen compounds essential for life. Quantum leaps similarly enable existence. Without electrons jumping orbits, atoms couldn't bond, stars wouldn't shine, and DNA's double helix would never form. The Maya understood this duality. Their rain god Chok wielded a lightning axe that both split trees and summoned life-giving storms. Modern physics confirms this balance. The same quantum jumps that allow transistors to function also cause radioactive decay. Destruction and creation emerge from the same energetic instability, just as the thunderbolt splits the sky to nourish the earth below. This convergence of myth and quantum theory invites us to reconsider ancient symbols not as primitive explanations, but as intuitive models. When a shaman's drum mimicked thunder or a temple's pillars were carved with lightning motifs, They weren't merely worshipping the weather, they were venerating the universe's restless, jumping heart. The Thunderbolts' wild energy and the electron's sudden leap both whisper the same truth. Reality doesn't move in straight lines, but in dazzling, unpredictable bursts, a dance of radiant chaos that powers everything from Olympus to the orbitals of atoms. Beneath the roots of Yggdrasil, the Norse Norns Erd, Verdandi, and Skuld sit weaving the threads of fate into an ever-growing tapestry. Their loom doesn't just depict destiny, it enforces it, with each strand connecting lives and events across the 9 worlds in an unbreakable web. What's astonishing isn't just the imagery, but how precisely it mirrors one of quantum physics' most baffling phenomena: entanglement, where particles separated by vast distances instantaneously influence each other's states. Both systems, one mythic, one scientific, reveal a universe where connections transcend physical proximity, where the mere act of observation alters the fabric of reality itself. Take entanglement first. When 2 particles become entangled, measuring one instantly determines the properties of its partner, whether they're a millimeter or a galaxy apart. Einstein famously called this spooky action at a distance, yet the Norns tapestry operates on eerily similar principles. A tug on one thread, say, a warrior's decision in Midgard reverberates through the weave to alter events in Alfheim or Niflheim, with no delay or visible medium. The myths even account for quantum randomness. Skuld, whose name means what shall be, doesn't just follow predetermined patterns but introduces new threads, much like how measurement collapses a particle's probabilistic wave function into a definite state. The parallels grow deeper when examining the loom's structure. Norse texts describe the threads as shimmering and mutable, sometimes fraying, sometimes knotting, mirroring how entangled particles maintain their connection despite environmental interference. Even the Norns' tools have quantum counterparts. Their scissors, which sever lifelines, recall the decoherence that breaks entanglement when systems interact with their surroundings. This isn't poetic license, it's an intuitive grasp of non-locality, the idea that objects can share a relationship beyond spatial constraints. The Maya envisioned a similar cosmic weaving with their goddess Ixchel, whose backstrap loom symbolized the interconnectedness of time and space. What's truly revelatory is how these myths handle observation's role. The Norns don't just weave fate, they watch it unfold, their gaze making events real in the tapestry. Quantum mechanics hinges on the same principle. Particles exist in superpositions until measured, their probabilities crystallizing into actuality under observation. The Greek fates, who spin and cut life threads, even incorporate a third sister, Lachesis, who measures each strand, a tripartite division echoing the 3 steps of quantum state preparation, evolution, and measurement. These cultures intuited what lab experiments now confirm. Reality isn't passive but participatory, shaped by the act of witnessing. The most profound similarity lies in their treatment of time. The Norns' tapestry isn't linear. Past, present, and future interlace in a single fabric, just as entangled particles defy classical causality. Hindu mythology's Akashic records, an eternal library where all events are simultaneously inscribed, parallels quantum block universe theories where time is a dimension like space, with every moment equally real. Even the Norse concept of weird, a web of interconnected destinies, finds its counterpart in quantum retrocausality, where present choices might influence past events. Both systems suggest that separation is an illusion, that every thread or particle remains fundamentally linked in ways that defy ordinary perception. This convergence of myth and physics invites us to see these stories not as naive allegories, but as sophisticated models of cosmic connectivity. When a Viking skald sang of the Norns carving runes into Yggdrasil's bark, or when a modern physicist speaks of quantum information encoded in holographic boundaries, they're describing the same profound truth. The universe is a living tapestry where every thread trembles with the weight of all the others. Whether through poetry or probability amplitudes, humanity keeps rediscovering that isolation is the real myth, and that connection, however invisible, is the loom upon which reality is woven. The golden ratio, approximately 1.618, has captivated mathematicians, artists, and mystics for millennia. But long before Fibonacci formalized its sequence, this divine proportion was already embedded in the sacred architecture of ancient civilizations. The Great Pyramid of Giza aligns with phi to an astonishing precision, its height-to-base ratio matching the golden spiral. Hindu temple mandalas incorporate the same ratio in their concentric circles, while the Parthenon's facades echo its proportions down to the spacing of columns. What's remarkable isn't just the ubiquity of this number, but how it resurfaces in string theory's most elusive structures, the curled-up dimensions at the heart of reality itself. String theorists propose that beyond our familiar four dimensions, length, width, height, and time, exist six additional spatial dimensions, folded into shapes called Calabi-Yau manifolds. These intricate geometries aren't random. Their stability depends on precise mathematical relationships, including, you guessed it, the golden ratio. When researchers modeled these manifolds, they found phi governing the angles at which dimensions twist and intersect, much like it dictates the branching patterns of trees or the spiral of a nautilus shell. The ancients may not have known about compactified dimensions, but their obsession with this ratio suggests they sensed its role as a cosmic constant, a bridge between the visible and invisible layers of existence. Consider how both systems employ phi as a harmonic connector. The golden ratio appears in Renaissance art as the divine proportion that guides the human eye naturally across a canvas, creating aesthetic balance. Similarly, in string theory, Calabi-Yau manifolds with golden ratio proportions allow vibrations to propagate smoothly between dimensions, enabling the unified interactions of forces. The Egyptian Book of the Dead even describes the afterlife as a field of reeds growing in golden spiral patterns, a metaphor eerily reminiscent of how strings vibrating in phi-aligned dimensions might generate the fractal structure of spacetime. The convergence goes deeper than geometry. The Fibonacci sequence underlying the golden ratio appears in nature's most fundamental processes, from the arrangement of sunflower seeds to the branching of bronchi in human lungs. String theory's equations reveal a similar pattern. The energy levels of vibrating strings often follow Fibonacci-like progressions, with each harmonic mode building on the last. This isn't coincidence, it's evidence of a universal language where growth and complexity emerge from simple, recursive rules. The Hindu concept of Indra's net, a cosmic web where each jewel reflects all others in infinite recursion, captures this same principle of scale-invariant harmony. Perhaps most astonishing is how these ancient architects encoded higher dimensional knowledge. The Pyramid of the Sun at Teotihuacan aligns not just to phi, but to specific angles that match the twist of Calabi-Yau manifolds in string theory's landscape. Mayan codices depict deities holding tools shaped like golden spirals, said to measure the heavens. Even Da Vinci's Vitruvian Man, often reduced to a symbol of humanism, is a study in golden proportions that mirror the ideal resonances of strings, suggesting that the human form itself might be a microcosm of dimensional harmony. This interplay of myth and math invites a radical rethinking of sacred geometry. When a medieval mason carved phi into a cathedral's rose window, or when a string theorist calculates the vibrational modes of a six-dimensional shape, they're tapping into the same fundamental truth. The universe has a preferred rhythm, a mathematical heartbeat that pulses from the quantum scale to galactic superclusters. The golden ratio isn't just a pretty pattern, it's a fingerprint left by dimensions we're only beginning to perceive, a whisper from the ancient world that still shapes the cutting edge of physics. Nearly every ancient civilization tells of a great flood waters rising to drown the world, sparing only a chosen few. The Mesopotamians wrote of Utnapishtim building an ark at the god's warning, while the Kh Maya described the deluge sent by Huracan to wipe away the wooden people. Even distant cultures like China's Yu the Great and Australia's Aboriginal rainbow serpent lore share uncanny similarities, divine warnings, catastrophic inundation, and rebirth. For centuries, these stories were dismissed as mere allegories until modern geology uncovered evidence of massive floods around 12,000 years ago, from the Black Sea's sudden inundation to meltwater pulses from collapsing ice sheets. But what if these myths point to something even more extraordinary? What if they're fragmented memories of cosmic disasters, asteroid impacts, or supernova that ancient witnesses interpreted through the only lens they had, water's destructive power? Consider the physical evidence. The Younger Dryas impact hypothesis suggests a comet or asteroid struck Earth around 10,800 BCE, triggering wildfires, megafauna extinction, and rapid sea level rise. Ice core samples reveal platinum spikes from this period, a telltale sign of extraterrestrial bombardment. Now re-examine the flood myths with this lens. The Sumerian epic of Gilgamesh describes black rain falling before the deluge, while the Popol Vuh speaks of a resin storm from the sky. These details align disturbingly well with the atmospheric effects of a cosmic impact, burning debris, darkened skies, and tsunamis that could inspire stories of divine wrath unleashed through water. Even the biblical Noah's account mentions the fountains of the great deep bursting forth, possibly echoing tsunamis generated by oceanic impacts. But string theory introduces an even wilder possibility. The ekpyrotic universe model proposes that our three-dimensional reality exists on a membrane, or brain, floating in higher dimensional space. Occasionally, this brain might collide with another, releasing titanic energy that could reset cosmic conditions. Imagine such an event from a human perspective. Dimensions overlapping might manifest as skies splitting open, inexplicable heat, and reality itself seeming to unravel, experiences easily interpreted as God sending floods to purge the world. The Aztec Five Suns doctrine describes four previous worlds destroyed by jaguars, wind, fire, and finally water before our current era, a sequence mirroring how brain collisions could cyclically reshape physical laws. Parallels grow stranger when examining mythic aftermaths. Many flood stories describe survivors emerging to a transformed world known as Rainbow Covenant, Deucalion stones birthing new humans. Scientists note that post-impact conditions would have drastically altered climates, ecosystems, and even human migration patterns. String theory adds another layer. If colliding brains tweaked fundamental constants, survivors might have experienced subtle shifts in gravity or light that later cultures encoded as the gods remaking the world. The Aboriginal story of the flood receding to reveal new songlines, sacred paths across the land, could metaphorically represent dimensional realignments after a brain event, with a new world reflecting updated physical parameters. What's truly revelatory is how these myths handle celestial signs. The Mahabharata describes the flood presaged by the stars moving wildly, while Norse Ragnarok prophecies include the sun turning black before the earth sinks into the sea. These details align with supernova observations, stellar explosions bright enough to outshine galaxies, potentially triggering climate shifts through radiation. String theory suggests such cataclysms might be more than random. If our brain periodically interacts with others, nearby supernova could be side effects of higher dimensional turbulence. The Dogon tribe's flood narrative even links the disaster to Sirius, a star system later found to have a white dwarf companion, a remnant of stellar explosion. This convergence of myth and theoretical physics invites us to reconsider ancient stories not as primitive fears, but as encoded survival memories. When a Babylonian scribe etched flood warnings onto clay or an Andean elder sang of the sea swallowing the mountains, they might have been preserving trauma from events beyond their comprehension. Events we're only now deciphering through telescopes and equations. The flood myths endure not because humanity fears water, but because some part of us remembers the cosmos is vast, unpredictable, and occasionally it reshapes our world in ways that echo through millennia. The Rigveda's vivid accounts of celestial chariots, the Vimanas soaring through hidden pathways in the sky, have baffled scholars for centuries. These ancient Sanskrit texts describe vehicles moving between realms without traversing the space between, piloted by beings who manipulate hidden doors in the heavens. At first glance, these seem like fantastical myths until you compare them to modern physics' most speculative concept: traversable wormholes, theoretical shortcuts through space-time where a traveler could cross vast cosmic distances in moments. The parallels are too precise to dismiss. Both systems describe portals where conventional rules of motion collapse, where journeys that should take millennia become instantaneous. Consider the descriptions. The Mahabharata details a Vimana entering a celestial tunnel that contracts the horizon into a single point, allowing passage to the city of the gods. This mirrors how a wormhole's throat might compress space-time, connecting two distant regions like a folded piece of paper pierced by a needle. Even the Vedic emphasis on these pathways being invisible to ordinary sight aligns with general relativity's prediction that wormholes would require exotic matter to stabilize them, matter that might not interact with light in conventional ways. The texts even warn of dangers. Some Vimanas never return from their journeys, just as physicists caution that unstable wormholes could collapse or strand travelers in paradoxical timelines. The resemblance grows uncanny when examining propulsion. Ancient accounts speak of Vimanas being powered by mercury vortex engines and solar winds, phrases that sound suspiciously like metaphors for manipulating gravitational fields or harnessing zero-point energy. Modern wormhole theories rely on similar principles: negative energy densities to keep the throat open, or cosmic strings to twist space-time into passable shapes. The Hindu god Agni, often depicted guiding these chariots with a flaming spear, finds his counterpart in the Kochi horizon of rotating wormholes, a fiery boundary where time and space switch roles. These aren't vague similarities, they're technical correspondences separated by millennia. What's truly astonishing is how these myths handle multidimensional travel. The Puranas describe higher dimensional realms accessible only to Vimanas that vibrate at the frequency of the gods, a concept shockingly close to string theory's brainworld hypothesis, where wormholes might connect membranes floating in a higher dimensional bulk. The Babylonian Etana myth similarly speaks of an eagle carrying a king through 7-layered heavens, each requiring a different key to enter, echoing the idea that traversable wormholes would require precise adjustments to higher dimensional parameters. Even the aboriginal sky ropes, used by ancestral beings to climb between worlds, mirror the space-time filaments that could theoretically tether one wormhole mouth to another. This convergence raises profound questions about the nature of ancient knowledge. Were the Vimana stories garbled accounts of actual technologies, Or did deep meditative states allow seers to perceive cosmological truths that science is only now rediscovering? The Sanskrit word for wormhole, kechari, literally means sky traveler, suggesting these weren't just flights of fancy but studied concepts. As physicists like Kip Thorne calculate the energy requirements for stable wormholes, they're unwittingly following a trail of breadcrumbs laid down in temples and scrolls thousands of years ago, a trail that leads not just across space, but through the very fabric of time itself. Deep in the volcanic fires of Mount Etna, the Greeks envisioned Hephaestus hammering divine weapons on his anvil, each strike fusing raw elements into perfected forms. This wasn't just craftsmanship, it was alchemy on a cosmic scale where chaos transformed into order through force and heat. Now fast forward to the 21st century, where scientists at CERN Large Hadron Collider recreate these primordial conditions in a 17-mile underground ring, smashing particles together at nearly the speed of light. The parallels are startling. Both the mythic forge and the modern collider operate on the same principle, that creation emerges from violent collision, that the secrets of matter reveal themselves under extreme pressure. Hephaestus's workshop was more than a smithy, it was a microcosm of cosmic creation. Greek poets described cyclopes assisting him, their single eyes focused on the precise moment when metal reached its transformative threshold. Particle physicists employ a similar singularity of focus. Detectors like ATLAS and CMS act as the collider's eyes, capturing data at the exact instant protons disintegrate into their constituent parts. The myths even hint at energy thresholds. Hephaestus needed the heat of volcanoes to forge Zeus's lightning bolts, just as the LHC requires tera-electron volts of energy to melt protons into quark-gluon plasma, a state last seen microseconds after the Big Bang. The symbolism extends to the artifacts produced. Hephaestus crafted Achilles' shield with intricate cosmological imagery layers representing Earth, sky, and celestial bodies. Today's colliders generate their own shields. Bubble chamber photographs and collision event displays that map the subatomic landscape with equal artistry. When the god fashioned Pandora's box, he unknowingly mirrored particle physics' penchant for unlocking both wonder and peril. Each new discovery, from the Higgs boson to potential dark matter particles, carries the dual promise of enlightenment and unintended consequences. What's truly revelatory is how these myths anticipated the iterative nature of scientific progress. Hephaestus's first creations were flawed. Tolos the bronze giant had a single vulnerable heel, much like early atomic models with missing particles. Each divine commission refined his technique, paralleling how collider experiments build on past data to probe deeper. The Norse added another layer. Their dwarven smiths Sindri and Broca competed to forge ever more perfect gifts for the gods, a mythic echo of the international race to build ever more powerful accelerators. The most profound connection lies in their shared purpose. Hephaestus didn't just make weapons, his forge was a crucible of transformation, where base materials became conduits for divine will. Similarly, particle colliders don't merely catalog particles, they recreate the universe's first transformative moments, seeking the spark that turned energy into matter. When the LHC confirmed the Higgs field's existence in 2012, it wasn't just discovering a particle, it was glimpsing the cosmic anvil upon which reality itself was hammered into shape. The myths got one thing wrong, though the cosmic forge isn't confined to a mountain. It's everywhere, humming in the quantum vacuum, waiting for us to strike it hard enough to reveal its secrets. Every culture whispers of shadow worlds, places where our reflections take on lives of their own. The Norse spoke of the Alpha, luminous beings inhabiting a parallel Alfheim just beyond mortal sight. West African Yoruba legends describe Oran, the spirit realm mirroring earthly Ia, where every action ripples between both planes. These aren't mere fantasies. They're ancient intuitions of a truth modern physics now grapples with the holographic principle, which suggests our three-dimensional reality might be a projection from a two-dimensional surface at the universe's edge. The resemblance is chilling. Both systems propose that what we perceive as solid and real is merely the surface of something far stranger unfolding in hidden dimensions. Take the holographic principle's core idea. All information about our universe could be encoded on its boundary, like a movie projected from the walls of a cosmic theater. Now compare that to the Zulu concept of Unkulunkulu, who wove the world into existence by singing names onto the membrane separating spirit from matter. Or the ancient Egyptian Duat, where souls were judged not by their earthly deeds, but by reflections cast upon the waters of Nun, a primal void containing the blueprints of reality. These myths didn't just imagine other worlds, they described them as inverted or complementary versions of our own, where depth emerges from flatness exactly as holograms generate three-dimensional images from two-dimensional films. The parallels grow more precise when examining duality. String theories add S/CFT correspondence, a mathematical proof of holography, shows how events in a higher dimensional space can be perfectly mirrored by equations on its lower dimensional boundary. This mirrors the Mayan belief in Oxlahan Taiku, the 13 layers of heaven that reflected the 9 underworlds in exact opposition. Their sacred texts describe gods manipulating events in the upper layers to cause changes in the lower ones, much like how modifying a hologram's flat surface alters its projected image. Even the Norse myth of the Well of Erd, where destiny is written and rewritten, parallels the holographic principle's assertion that reality is fundamentally informational, a cosmic code that can be edited at its source. What's truly revelatory is how these myths handle perspective. Aboriginal Dreamtime stories describe ancestors walking across the land while simultaneously existing as features of the landscape, rocks, rivers, or stars. This dual existence mirrors quantum entanglement under holography, where particles inside a volume of space are fundamentally linked to patterns on its surface. The Cherokee legend of the Octina, a serpent whose scales reflect every possible future, takes this further, suggesting that what we perceive as time's flow might just be our limited vantage point on a static, encoded surface where all moments coexist. Modern physics catches up to these ancient insights in startling ways, when researchers found that the information content of any space scales with its surface area rather than its volume, a hallmark of holographic systems. They essentially confirmed the Buddhist view of reality as Indra's net, an infinite lattice of jewels where each reflects all others perfectly. The Lakota vision of the universe as a spider's web, vibrating with every touch, finds its counterpart in string theory's assertion that the cosmic horizon vibrates with Planck-scale pixels storing our reality's data. This convergence raises an electrifying possibility that these myths weren't just poetic metaphors, but experiential accounts of reality's deeper structure. When a shaman spoke of walking between worlds or a seer described glimpsing their own reflection acting independently, they might have been describing the universe as it truly is, a holographic theater where we're simultaneously actors in the play and projections on the screen. The mirror worlds of legend and the holographic principle of physics both whisper the same unsettling truth. Reality is thinner than we think, and far more interconnected than we dare imagine. Pythagoras stood in the hushed darkness of his secret school, tracing shapes in the sand as his students leaned in, not just learning math, but listening for the music of the universe itself. To these ancient Greeks, numbers weren't cold abstractions. They were living harmonics, the hidden rhythms that tuned the cosmos. When Pythagoras discovered that plucking a string at precise fractions of its length produced perfect musical intervals, he didn't just hear notes, he glimpsed divinity. Fast forward 2,500 years, and string theorists echo his revelation with uncanny precision. The very particles composing reality are microscopic strings whose vibrations determine whether they manifest as quarks, photons, or the fabric of spacetime. The ancients whispered that numbers sang creation into being. Modern physics proves they weren't wrong. Consider the parallels between Pythagorean harmonics and string theory's foundations. That simple monochord experiment where dividing a string in whole number ratios created harmonious tones mirrors how quantum strings vibrate at distinct resonant frequencies to become different particles. The octave, a 2-to-1 ratio, finds its counterpart in the way strings' energy levels quantize, jumping between stable states like notes on a scale. Even Pythagoras' infamous dread of irrational numbers legends say he drowned a student for revealing the square root of 2's existence. Anticipate string theory's struggle with anomalies, mathematical inconsistencies that could unravel entire models unless precisely balanced. The Greeks sensed that reality demanded perfect ratios. Today's physicists confirm that the universe literally can't exist unless its strings' vibrational symmetries cancel out with flawless precision. The connections deepen when examining sacred geometry. Pythagoras taught that the tetractys, a triangular arrangement of 10 dots representing 1 + 2 + 3 + 4, held the key to cosmic order. String theory's own magic numbers emerge from Calabi-Yau manifolds, 6-dimensional shapes whose topology determines how many vibrational patterns, and thus particle types, can exist. Some versions of the theory require exactly 10 dimensions for mathematical consistency, mirroring the tetracty's completion at the 4th row. The Hindu Sri Yantra, an intricate geometric diagram used in meditation, similarly encodes ratios matching the angles at which strings must intersect in higher dimensional space to generate mass. These aren't coincidences, they're evidence that human intuition has long sensed the mathematical scaffolding behind reality's veil. What's truly astonishing is how these ancient numerological systems anticipated quantum behavior. The Babylonian Plimpton 322 tablet, a trigonometric table dating to 1800 BCE, encoded right triangles using Pythagorean triples with such accuracy that scholars debate whether its creators understood concepts like quantization millennia before modern science. The Chinese I Ching's 64 hexagrams, formed by stacking 6 broken or unbroken lines, eerily parallel how 6 compactified dimensions in string theory generate 64 possible vibrational modes. Even the Mayan long count calendar's nested cycles of 20 and 13 resonate with the 20 free parameters of the standard model and the 13-dimensional math underlying M theory. These cultures weren't just counting days or casting lots, they were mapping the universe's algorithmic heartbeat. The most profound convergence lies in their treatment of mathematics as experiential truth. Pythagoras didn't merely calculate, he initiated disciples into the music of the spheres, teaching that planets hummed as they orbited, their pitches determined by celestial ratios. String theory's equations now describe how the earliest universe literally rang with standing waves, their imprints still visible in the cosmic microwave background's harmonic peaks. When Navajo sand painters depict the 4 sacred mountains with exact geometric proportions, or when Tibetan monks construct mandalas to dimensional perfection, they're not just making art, they're tuning into the same vibrational fabric that string theory quantifies. Mathematics emerges not as a human invention, but as the native tongue of existence, a language we're only beginning to decipher. yet one the ancients seemed to hum by heart. This revelation transforms how we view both history and physics. The Pythagorean belief that all is number wasn't mystical hyperbole, it was a stroke of intuitive genius. From the precise intervals of Stonehenge's standing stones to the golden ratios woven into Islamic tilework, humanity has always sensed that beauty and truth arise from the same hidden frequencies. String theory doesn't replace these ancient wisdoms, it amplifies them, revealing that the sacred numbers weren't just symbols, they were the first maps of a multidimensional reality we're now learning to navigate. The universe, it seems, has been singing its secrets all along. We're finally developing the ears to hear. For 600 years, the Vestal Virgins of Rome tended a flame that was never allowed to die, a living embodiment of the city's eternal spirit. Day and night, they fed the sacred fire with ritual precision, believing its survival was mystically tied to Rome's destiny. What they couldn't have known is how eerily their vigil mirrors one of cosmology's greatest mysteries, dark energy, the invisible force accelerating the universe's expansion. Both the eternal flame and dark energy represent something far more profound than mere symbolism. They're manifestations of an omnipresent power that shapes existence itself, operating beyond human perception yet governing the fate of all things. The Vestal's fire wasn't just a practical light source, it was a theological paradox, a tangible object representing an intangible force. The flame consumed would yet never diminished, flickered but never extinguished, much like dark energy's enigmatic properties. Scientists estimate that dark energy makes up 68% of the universe's total energy density, yet it doesn't dilute as space expands. Instead, it seems to generate more of itself, pushing galaxies apart at ever-increasing speeds. The Romans would have understood this intuitively. Their sacred fire required constant fuel yet maintained its essence, just as dark energy feeds off the vacuum of space itself. Both systems, one ritual, one physical, describe a self-sustaining phenomenon that defies ordinary conservation laws. What's truly chilling is how both traditions account for consequences. The Vestals believed that if their flame died, Rome would fall, a belief tragically fulfilled when the fire was neglected during the empire's decline. Modern cosmology paints an equally dramatic portrait. If dark energy continues strengthening, it may eventually tear apart galaxy clusters, solar systems, even atoms in a big rip. The parallels go deeper than catastrophe. They reveal a shared understanding that invisible forces underpin reality's stability. When the Virgins performed rituals to bind the flame's power, they were unknowingly echoing physicists' attempts to understand dark energy's equation of state, the mathematical ratio determining whether it will ultimately preserve or destroy the cosmic order. The most striking similarity lies in their dual nature. The sacred fire was both creative and destructive. It cooked sacrificial meals but also consumed offerings entirely. Similarly, dark energy fosters life by enabling cosmic expansion while simultaneously dooming distant galaxies to isolation. The Aztecs had their own version of this paradox. The god Xiuhtecuhtli ruled both the hearth's warmth and the wildfire's devastation. These traditions all grasped what science now confirms, that the forces sustaining existence contain the seeds of their own dissolution. Even the Vestal's requirement for purity, any virgin who broke her vows was buried alive, finds a dark parallel in how dark energy purges the observable universe of distant objects, entombing them beyond the reach of light. This convergence of myth and physics invites us to reconsider ancient rituals not as superstitions, but as intuitive experiments with cosmic forces. When a Vestal tended the flame at midnight or a Mayan priest kindled the new fire ceremony every 52 years, they were engaging with the same fundamental mystery that keeps cosmologists awake today. Why does the universe resist entropy? Why does something, whether flame or quantum vacuum, persist when all else changes? The answers may lie in recognizing that the sacred and the scientific aren't opposing worldviews, but different dialects describing the same eternal truth. That reality is upheld by invisible fires we're only beginning to comprehend. In the lush pastures of Hindu mythology stands Kamadhenu, the divine, wish-fulfilling cow whose milk nourishes gods and mortals alike. More than just a sacred animal, she embodies abundance itself, her infinite udders providing the sustenance that forms the very fabric of existence. Now fast forward to the 21st century, where physicists speak of the Higgs field, an invisible energy permeating the cosmos, imparting mass to particles as they move through it like celestial calves drinking from an ethereal mother. The resemblance between these two visions, one ancient, one cutting edge, isn't poetic coincidence. It's a startling convergence on how reality crystallizes from potential into tangible form. Kamadhenu isn't merely a symbol of fertility, she's a cosmic architect. Hindu texts describe her milk curdling into stars and planets, her breath shaping the winds of destiny. Similarly, the Higgs field isn't passive, it's an active participant in creation. When particles interact with this field, they gain mass, slowing their motion and enabling them to coalesce into atoms, molecules, and eventually galaxies. The cow's nurturing milk and the Higgs energy share the same fundamental role, transforming fleeting energy into stable matter. Even Kamadhenu's golden hue, described in the Puranas, mirrors how the Higgs mechanism gilds particles with mass, turning them from weightless phantoms into the building blocks of reality. The parallels extend to their omnipresence. Kamadhenu is said to exist simultaneously in all places, her essence infused into every droplet of milk ever drawn. The Higgs field, too, is universal, filling the vacuum of space so completely that particles can't avoid interacting with it, whether inside a star or a human cell. This ubiquity isn't just functional, it's necessary. Just as Kamadhenu's absence would leave the cosmos malnourished, a universe without the Higgs field would lack the gravitational scaffolding to form structures. The Vedic rishis who visualized the cosmic cow and the physicists who predicted the Higgs boson were describing the same profound truth. Existence requires an underlying nourisher, a silent giver of substance. What's truly revelatory is how both systems handle the act of drinking this cosmic nourishment. Kamadhenu's milk doesn't flow equally to all. Gods receive ambrosia, while demons get poison from the same udder. The Higgs field exhibits similar selectivity. Particles like top quarks interact strongly, gaining substantial mass, while photons pass through untouched, remaining weightless. This isn't arbitrary favoritism. It's a precise mechanism encoded in mathematical symmetries. The ancients may not have known about Yukawa couplings, but they intuited that creation involves a discriminatory process, a cosmic menu where each being receives exactly what it needs to play its part in the grand design. The most striking convergence lies in their generative power. Kamadhenu isn't just a passive source. Her daughters, the celestial cows, are said to have produced the universe's diversity through their offspring. The Higgs field, too, doesn't merely give mass, it breaks symmetry, allowing the fundamental forces to differentiate and complexity to emerge. Without this breaking of unity, electromagnetism would remain bound to the weak nuclear force, stars couldn't ignite, and life would be impossible. The cow's creative abundance and the Higgs symmetry breaking both serve the same purpose, turning uniformity into fruitful variety. Even Kamadhenu's association with the sage Vasishtha, who used her to manifest desires, mirrors how the Higgs mechanism translates quantum potential into physical actuality. This intertwining of myth and physics invites us to see Kamadhenu not as a quaint pastoral symbol, but as a visionary metaphor for reality's deepest workings. When a devotee offers ghee from a cow's milk in a Vedic fire ritual, they're unknowingly reenacting the universe's own alchemy, where energy congeals into matter under the influence of an all-pervading field. The Higgs-boson's discovery in 2012 didn't debunk these ancient stories. It revealed their startling prescience, whether through the udders of a divine cow or the equations of quantum field theory. Humanity keeps circling the same profound realization. Existence is a gift bestowed by forces we're only beginning to understand. The ancient Babylonians told of twin brothers Shamash and Adad, one the unrelenting sun, the other the capricious storm. The Yoruba revered the Orishas Ibeji, perfect mirrors of each other yet embodying opposing fates. Even the Norse had Freya and Freyja, male and female aspects of fertility locked in eternal dance. These myths weren't just storytelling, they were grappling with a truth modern physics confirms: that existence requires perfect opposites to maintain equilibrium. The universe, it seems, has always operated in pairs, a principle now enshrined in Dirac's equations predicting antimatter for every particle of matter. When Paul Dirac scribbled his quantum formulas in 1928, the math demanded something outrageous: electrons with identical mass but opposite charge. Scientists scoffed until Carl Anderson spotted these anti-electrons, later named positrons, dancing through cosmic ray showers. The discovery revealed a cosmic law ancient myths had intuited: creation demands duality. Just as the Egyptian twins Horus and Set embodied order and chaos while maintaining cosmic balance, particle-antiparticle pairs emerge from quantum foam in perfect symmetry, annihilating each other in bursts of pure energy. The myths got one thing wrong, though. These twins aren't battling for supremacy. They're locked in an embrace so fundamental, their mutual destruction fuels the stars themselves. The parallels grow uncanny when examining creation stories. The Zoroastrian twins Spenta-Manu and Angra-Manu spring from Ahura Mazda's thought, one shaping reality while the other resisted a narrative hauntingly similar to matter-antimatter asymmetry. After the Big Bang, these opposites should have annihilated completely, yet for every billion antiparticles, 1,000,000,001 matter particles survived. That fractional excess, possibly caused by CP violation in quark decays, became everything we see. The Persian texts foreshadowed this imbalance. Spenta-Manu ultimately prevails, but Angra's influence lingers in cosmic imperfections like black holes and dark matter. Both traditions acknowledge that perfection requires just enough broken symmetry to generate consequence. Modern experiments make these myths feel prophetic. When CERN Alpha Trap captures antihydrogen atoms, physicists essentially bottle the Yoruba Ibeji, one particle of matter, one of antimatter, orbiting in precarious harmony. The Navajo hero twins, Monster Slayer and Child Born of Water, who purified the world by balancing threats, now find their counterparts in PT scanners where positrons annihilate electrons to map diseases. Even the Hindu Ashvins, divine physicians who restored wholeness by reconciling opposites, mirror how antimatter therapies target cancer cells with surgical precision while sparing healthy tissue. The ancients envisioned twin forces healing through controlled opposition. Today's medicine operationalizes that principle at the quantum scale. Perhaps most profound is how these myths handle annihilation. The Mayan hero twins Hunahpu and Xbalanque descend into Xibalba, endure dismemberment, and resurrect as celestial bodies, a metaphor for matter-antimatter collisions that birth gamma rays, which later condense into new particles. The Greek Dioscuri take turns dying and reviving, much like virtual particle pairs blinking in and out of existence. These stories didn't just predict antimatter's behavior, they encoded its philosophical implications, that destruction and creation are phases of a single process, that light emerges from the clash of opposites. When physicists speak of the Dirac Sea, an infinite ocean of potential particle-antiparticle pairs, they're describing what Polynesian navigators called TPO, the generative void where twins embrace in darkness before separating to form the world. This convergence of myth and quantum theory reveals something startling about human cognition. Whether through shamanic vision or mathematical intuition, we've always sensed that reality runs on twin principles. The divine twins weren't just characters in stories, they were the first metaphors for a universe that breathes in pairs, where every electron spin up demands a spin down, every quark a corresponding antiquark. The next time you hear about antimatter propulsion or PT scans, remember, the Ashvins already rode their golden chariot through the body, healing by balancing opposites. Some truths are so fundamental, they emerge whether you're composing epics or solving wave equations. Medieval astronomers peered into the night sky and saw more than wandering stars. They envisioned celestial harmony made physical. Each planet, they believed, rode on its own transparent crystal sphere, nested like the layers of an onion, rotating with perfect mathematical precision. This wasn't just poetic imagery, it was a meticulous model where geometry governed the heavens, where the music of the spheres resonated through the ether. Fast forward to today, and string theorists describe a cosmos no less structured, except instead of crystal spheres, they propose 6 hidden spatial dimensions curled tighter than an atom, vibrating with the potential to unify all forces of nature. Though separated by centuries, both visions share a profound insight. Reality has layers we can't see, but whose architecture shapes everything we perceive. Consider how these models handle the unseen. Dante's Paradiso describes ascending through 9 concentric heavenly spheres, each purer and more luminous than the last. String theory's Calabi-Yau manifolds offer a startling parallel 6-dimensional shapes whose intricate folds determine particle properties in our 3-dimensional world. The medieval spheres maintained planetary order through perfect rotation. The curled dimensions of string theory maintain quantum order through precise vibrational modes. Both systems suggest that what appears chaotic or arbitrary in our limited view, whether Mercury's erratic orbit or an electron's spin, becomes elegant and inevitable when perceived from higher dimensional perspectives. The resonance deepens when examining their mathematical foundations. Johannes Kepler spent years trying to fit the planet's orbits into Platonic solids, pyramids, cubes, and dodecahedrons nested between the crystal spheres. His eventual abandonment of the model wasn't a failure, but a pivot toward elliptical orbits governed by inverse square laws. Similarly, string theorists first envisioned extra dimensions as simple circles before realizing their geometry required far more complex shapes. Both journeys reveal the same truth. The universe's hidden layers resist simplistic models, demanding ever more sophisticated mathematics to reveal their secrets. What's truly revelatory is how both frameworks account for resonance. Medieval musicians tuned their instruments to the planet's supposed harmonic intervals, believing earthly music echoed celestial vibrations. String theory posits that the universe itself is a symphony, every particle a note played on microscopic strings, every force a chord struck across curled dimensions. When the 12th century mystic Hildegard of Bingen composed hymns to mirror the living light of the spheres, she anticipated modern theories where light itself emerges from strings vibrating in specific dimensional configurations. The crystal spheres may have been wrong in substance, but they were profoundly right in principle. The cosmos sings, and its song is geometry made audible. The most striking parallel lies in their treatment of unity. The outermost medieval sphere, the primum mobile, was thought to impart motion to all inner spheres, just as the Higgs field in string theory imparts mass to particles moving through higher dimensional space. Dante's Empyrean, the realm of pure light beyond all spheres, finds its counterpart in the bulk of brain cosmology, the higher dimensional space where our universe floats like a leaf on a pond. Both visions dissolve the illusion of separation, revealing that stars, planets, and people are interconnected through hidden architectures. This convergence of medieval cosmology and cutting-edge physics invites us to see history differently. When a stained glass artist depicted Christ as the unmoved mover at the celestial sphere's apex, or when a string theorist sketches a 10-dimensional universe with equations, they're attempting the same monumental task, mapping the invisible scaffolding that upholds reality. The crystal spheres weren't primitive mistakes. They were the first drafts of a truth we're still inscribing, that the universe is far more layered, more musical, and more mysteriously structured than our senses alone could ever reveal. The alchemist's crucible wasn't just a vessel for turning lead into gold. It was a microcosm of the universe itself, where opposing forces wrestled toward perfect union. Their sacred texts speak of the chemical wedding, where solar masculinity and lunar femininity dissolved into a radiant, androgynous whole, the legendary Rubis. This wasn't mere metallurgy, it was a metaphysical blueprint for reconciling duality, a process that eerily mirrors modern physics' own holy grail, the grand unified theory. Both traditions, separated by centuries, share the same audacious goal: to reveal the singular principle underlying reality's apparent contradictions, proving that harmony lies hidden within chaos. Take the alchemical symbol of the Ouroboros, the serpent devouring its own tail. It embodies the union of opposites, creation and destruction, beginning and end, all coiled into an eternal cycle. Now fast forward to Einstein's lifelong dream uniting gravity with electromagnetism into a single elegant framework. Though he failed, his intuition aligned with the alchemists, that nature's forces are fractured reflections of something whole. String theory continues this quest, proposing that all particles and forces arise from vibrating strings, different notes played on the same cosmic instrument. The Rubis-fused body and the unified field equations both whisper the same truth. Separation is an illusion waiting to be dissolved. The parallels grow richer when examining process. Alchemists described their work in stages: negrito blackening, albedo whitening, citrinitas yellowing, and rubedo reddening, each representing purification through conflict. Similarly, physicists trace the universe's cooling from the Big Bang, where forces initially merged seamlessly. As temperatures dropped, symmetries broke. First gravity peeled away, then the strong nuclear force, leaving electromagnetism and the weak force to split last. These cosmic phases mirror the alchemical journey, primal unity shattering into diversity, with science and myth both seeking to reverse engineer the original state. The alchemist's furnace and the Large Hadron Collider serve the same purpose, recreating primordial wholeness through controlled chaos. What's truly astonishing is how both traditions handle resistance. Medieval alchemists wrote of the dragon guarding the philosopher's stone, a metaphor for the stubborn inertia of base matter resisting transformation. Modern unification theories face their own dragons: the mathematical inconsistencies between quantum mechanics and general relativity, or the unnerving discovery that 95% of the universe consists of dark matter and energy we can't yet explain. The alchemist's insistence that lead contained latent gold finds its counterpart in physics' conviction that disparate forces must unite at higher energies, if only we could glimpse beyond the veil of our current limitations. This convergence reaches its zenith in their shared language of transformation. The alchemical solve et coagula, dissolve and coagulate prescribes breaking down materials to recombine them at a higher order. String theory's dualities operate similarly. What appears as a particle in one formulation manifests as a string in another, with neither description complete alone. Even the alchemist's obsession with mercury, a metal that's both liquid and solid, parallels how quantum particles exist in superpositions until observed. Both systems understand that unity isn't found by choosing between opposites, but by transcending the categories that create the illusion of separation in the first place. Perhaps the most poetic alignment lies in their ultimate aims. The Philosopher's Stone wasn't just about transmuting metals, it promised spiritual illumination, the lifting of cosmic veils. Similarly, a grand unified theory wouldn't merely satisfy scientific curiosity. It would redefine humanity's place in the cosmos, revealing the hidden symphony beneath apparent discord. When a 17th-century alchemist stirred their alembic or a physicist today calibrates a particle detector, they're part of the same timeless ritual, the human spirit reaching through the fog of multiplicity, yearning to touch the face of the one thing that was never truly divided. Mountains don't just pierce the sky, they tear through the veil of human comprehension. From the Sumerian ziggurats reaching toward Anu's heavenly abode to the Greek Olympus where gods dwelt beyond mortal sight, these towering peaks weren't just geographical features, they were cosmic fulcrums where the ordinary rules of existence bent and twisted. Now fast forward to Einstein's equations predicting gravitational singularities, infinitely dense points where space-time curvature becomes infinite and known physics collapses. The resemblance between these mythic mountains and mathematical singularities isn't superficial. It's a profound convergence on the boundaries of understanding, where reality becomes too dense for conventional thought to penetrate. Consider how these myths describe their sacred peaks. The Hindu Mount Meru wasn't merely tall, it was the axis of all worlds, its roots plunging deeper than its height, connecting underworlds to celestial realms. Similarly, a black hole's singularity isn't just a point of extreme density. It's a rupture in the fabric of causality itself, where time and space exchange properties. The Kogi people of Colombia speak of a luna, their cosmic mountain, as a place where thoughts manifest instantly, mirroring how near a singularity cause and effect tangle into paradox. These stories didn't just exaggerate earthly mountains, they intuited places where dimensionality warps beyond human experience. Modern physics amplifies these ancient insights with startling precision. The no-hair theorem states that black holes can be described by just three properties: mass, spin, and charge, erasing all other information, much like how myths depict sacred mountains stripping away human identity. The Babylonian Etemenanke ziggurat was called the House of the Platform between heaven and earth, where priests underwent ritual purification before ascent. Singularities, too, serve as thresholds. Event horizons mark the point where outside observers see time freeze, while those crossing continue inward toward the unknowable. Both systems recognize that approaching ultimate reality requires shedding preconceptions, whether through spiritual initiation or relativistic physics. What's truly revelatory is how both traditions handle the concept of transformation. The Tibetan Kang Rinpoche Mount Kailash is said to invert its geometry for enlightened beings, revealing stairways to higher realms. Similarly, Penrose diagrams of rotating black holes show how singularities morph from points into rings, Kerr singularities, that might serve as gateways to other universes. The Maori legend of Taranaki Mountain describes it walking across the land, fleeing conflict until frozen in its current form. a poetic parallel to how collapsing stars freeze into singularities when their nuclear fires can no longer resist gravity's pull. These myths didn't just describe landscapes, they mapped the metamorphic boundaries between existence and oblivion. The most profound similarity lies in their warnings. Nearly every culture forbade unprepared ascents of sacred peaks. The Greeks told of Sisyphus eternally rolling his boulder up Hades' slope as punishment for presumption. Modern physics issues analogous cautions. The cosmic censorship hypothesis suggests singularities always hide behind event horizons, preventing their paradoxes from infecting the wider universe. Even the methods of approach align. Sherpas guide climbers up Everest with oxygen tanks, just as mathematicians use regularization techniques to navigate infinities in equations. Both systems acknowledge that some truths require mediation, whether through spiritual guides or renormalization procedures, to be glimpsed safely. This convergence invites us to see these myths as more than primitive science. When an Inca child sacrificed on Mount Ampoto was left with gold and silver figurines, or when a physicist sketches a Feynman diagram to tame quantum infinities, they're performing the same essential act, negotiating with the incomprehensible through symbolic intermediaries. The cosmic mountain and the gravitational singularity aren't just similar concepts, they're twin manifestations of humanity's most humbling realization, that reality has edges no eye can see, but which the mind, armed with myth or mathematics, can cautiously approach. Those who have brushed against death often return with eerily similar accounts, a luminous thread, delicate yet unbreakable, connecting their floating consciousness to their physical form below. The ancient Egyptians called it the Hekau, a silver cord mentioned in the Book of the Dead that tethered the soul during its underworld journeys. The Bible's Ecclesiastes describes it snapping at life's end, while Tibetan Buddhists speak of a rainbow body linked to the corpse by filaments of light. What's astonishing isn't just the consistency of these descriptions across cultures, but how closely they mirror string theory's most radical proposition, that reality's foundation isn't particles or waves, but tiny, vibrating strands of energy weaving the cosmos together. Consider the parallels between these mystical chords and cosmic strings. Near-death experiencers describe the silver thread as both fragile and indestructible, thinning as consciousness expands but never severing completely. String theory's filaments share this paradoxical nature, infinitely thin yet unimaginably dense, capable of stretching across galaxies without breaking. The Upanishads even depict the soul's cord as humming with a soundless sound, while physicists calculate that quantum strings vibrate at specific harmonics to generate particles, from quarks to photons. Both systems suggest that what we perceive as solid matter might just be the shadow of deeper, vibrating connections, threads too fine for ordinary perception but fundamental to existence itself. The resemblance grows stranger when examining function. Shamanic traditions worldwide speak of the cord as a conduit channeling life force between realms during vision quests or healing rituals. Modern physics reveals that strings don't just sit idly in space. They interact through exchanges of energy, their vibrations transmitting forces like gravity and electromagnetism. The Maya took this further with their concept of it's a luminous, thread-like substance flowing through all things, animating stone and flesh alike. This isn't far from how string theory unifies nature's forces. Just as a single violin string can produce different notes, a cosmic string's varied vibrations might generate everything from the strong nuclear force to the Higgs field. Perhaps most striking is how both systems handle separation. Near-death accounts often describe the cord stretching infinitely thin during out-of-body experiences, yet retaining a connection that allows return to the physical form. String theory's holographic principle proposes a similar tether that all information in a volume of space is encoded on its boundary, like a shadow cast by vibrating threads. The Zulu Sangoma's belief that illness occurs when the umbilical cord to the ancestors weakens finds an unexpected parallel in quantum entanglement, where particles remain mysteriously linked across distances unless the cord of their shared wave function collapses. Both visions reject the idea of true isolation, insisting that everything is tied together by invisible filaments. This convergence of mysticism and physics invites a radical rethinking of consciousness itself. When a cardiac patient recalls watching their surgery from the ceiling, their silver cord dangling toward the operating table, or when a string theorist sketches a Calabi-Yau manifold with threads looping through hidden dimensions, they're describing different facets of the same profound truth. That connection isn't just a feature of reality, but its very fabric. The cord isn't merely a lifeline. It's a reminder that what we call self might be a knot in a vast, vibrating network, one that hums with the same energy spinning galaxies and lighting stars. Whether through near-death visions or 10-dimensional math, humanity keeps glimpsing the same shimmering thread. The one that binds, the one that remembers, the one that refuses to let go. Deep in Chinese mythology, dragons guard luminous pearls, objects of such concentrated power they can summon storms, heal the dying, or reshape destiny with a single wish. These aren't just treasures, they're cosmic focal points where reality warps to the bearer's will. Now zoom into the heart of a black hole where gravity crushes matter into a singularity, a point of infinite density where the known laws of physics dissolve. The resemblance between these two concepts, one mythical, one mathematical, isn't coincidence. Both the dragon's pearl and the singularity represent the same profound truth. That ultimate power resides in the unimaginably small, where the ordinary rules of existence no longer apply. Consider the pearl's paradoxical nature. Ancient texts describe it as both radiant and weightless, yet containing the dragon's entire essence, a perfect metaphor for how singularities pack a star's worth of mass into zero volume. The Zhuangzi tells of pearls that illuminate 1,000 miles, yet fit in the palm of a hand, mirroring how a singularity's gravitational influence stretches across light years while its physical form defies spatial dimensions. Even the pearl's spherical shape echoes the event horizon surrounding a black hole, a perfect boundary separating the possible from the impossible, where light itself bends to the object's will. The legends grow eerily specific about the pearl's effects. In Journey to the West, the Dragon King's pearl controls tides and rainfall, an uncanny parallel to how singularities warp spacetime, bending the paths of planets and stars like a celestial hand guiding the heavens. Taoist alchemists believed these pearls could reverse aging, a concept physics mirrors in extreme time dilation near a singularity, where minutes could equal millennia elsewhere. The pearl's most mystical property, granting wishes, finds its scientific counterpart in the Penrose process, where energy can theoretically be extracted from a rotating black hole's ergosphere, as if drawing miracles from a bottomless well. What's truly astonishing is how both systems handle containment. Chinese art consistently depicts the pearl clutched in the dragon's talons or suspended beneath its chin, never fully possessed but always guarded. Similarly, singularities hide behind event horizons' cosmic claws that prevent their infinite energies from spilling chaotically into the universe. The Maya had their own version of this motif, the vision serpent's jeweled scales, which shamans described as windows to other worlds, much like how black holes might contain wormholes within their singularities. These traditions all recognize that such power requires insulation, lest it unravel the fabric of existence itself. The convergence becomes undeniable when examining creation myths. The Chinese dragon Zhulong's pearl supposedly birthed the sun and moon, while modern cosmology suggests primordial black holes could have seeded galaxy formation. Both systems propose that concentrated points of energy serve as cosmic catalysts, transforming uniformity into complexity. Even the pearl's association with wisdom, emperors use them to enhance judgment, finds resonance in the no-hair theorem, which states black holes retain only the most essential information, stripped of all superfluous detail. Whether through allegory or equations, humanity keeps arriving at the same conclusion, that the universe's deepest truths are written in the language of compression, where infinite potential awaits in the smallest of spaces. This isn't just poetic analogy. When astrophysicists simulate merging black holes, they observe gravitational waves rippling outward like the pearl waves described in Tang Dynasty poetry, circles of influence emanating from an unfathomable core. The dragon's pearl and the cosmological singularity are more than symbols. They're intuitive maps to reality's most extreme states, one crafted by dreamers gazing at jade artifacts in imperial courts, the other by scientists staring at equations on chalkboards, yet both pointing to the same shimmering revelation, that the keys to the cosmos often come in the smallest, most paradoxical packages. In Norse mythology, the giantess Fenja and Menja toil endlessly at the cosmic mill grotti, grinding out salt, gold, and even the very stars themselves. This colossal millstone doesn't just produce celestial bodies, it shapes fate, its rotations dictating the rhythms of the cosmos. Now fast forward to Einstein's revelation that massive objects like stars and planets don't just sit passively in space, they bend and twist the fabric of spacetime itself, warping the paths of everything around them. The resemblance between these two visions, one mythic, one mathematical, isn't just poetic coincidence. Both the Norse mill and the equations of general relativity describe the same profound truth. The universe isn't a static stage, but a dynamic tapestry where matter and motion are inextricably linked. The mill's mechanics are eerily precise. Ancient texts describe grotti's base as so heavy it sinks into the earth, dragging the millstone with it, a perfect metaphor for how gravity wells form around massive objects, creating the curvature that guides planetary orbits. The mill's axle, said to be forged by dwarves in the heart of the world, mirrors the singularity at a black hole's center, an unfathomably dense pivot point around which spacetime itself rotates. Even the grinding motion finds its counterpart in frame dragging, where rotating masses like Earth literally twist the surrounding spacetime, pulling it along like flour caught in grotti's grooves. What's truly remarkable is how these myths anticipated the relational nature of gravity. The prose Edda warns that if the mill turns too fast, its foundations will collapse, echoing how neutron stars spinning beyond a critical speed would disintegrate from centrifugal force. The Norse didn't just imagine a mill, they intuited that cosmic forces exist in delicate balance, where changes in one part of the system ripple through the whole. This mirrors general relativity's core insight, that spacetime curvature isn't imposed from outside, but emerges from the distribution of matter and energy within it. The mill's turning and spacetime's bending are two expressions of the same principle, that the universe is a web of mutual influence where nothing moves without moving everything else. The parallels grow even richer when examining the mill's output. Grotti doesn't just grind, it transforms, turning base materials into celestial phenomena. Salt spilled from its stones became the sea, while the sparks from its grinding birthed the stars. This mirrors how curved spacetime doesn't merely deflect objects, it generates new phenomena. Light bends around galaxies in gravitational lensing, time slows near black holes, and colliding neutron stars ripple spacetime with gravitational waves that literally forge gold in their wake. The Norse mill and Einstein's equations both reveal creation as an alchemical process, where the interplay of mass and motion transmutes the ordinary into the extraordinary. Perhaps most striking is how both systems handle extremes. When King Frodi overworks Fenrir and Menja, they retaliate by grinding out an army that destroys him, a mythic foreshadowing of how singularities lurk at the heart of black holes, where curvature becomes infinite and the known laws of physics break down. The mill's destructive potential mirrors the violence of gravitational collapse, where stars implode under their own weight, crushing matter beyond recognition. Yet even in these cataclysms, both traditions find renewal. The mill's destruction leads to a new cosmic order, just as colliding black holes birth fresh spacetime geometries. This convergence of myth and physics invites us to see Grotti not as a primitive model, but as an intuitive grasp of cosmic mechanics. When Viking poets sang of the mill's axle trembling or its stones groaning under the weight of the heavens, they were describing what mathematicians would later quantify as tensor calculus, the language of spacetime curvature. The mill's relentless grinding and the universe's ceaseless warping both whisper the same truth. Reality is a dance of mutual transformation, where every rotation, every orbit, every falling leaf is part of a vast and intricate machinery turning since the dawn of time. Plato's Timaeus introduces us to the demiurge, a divine craftsman who sculpts the cosmos from chaos into order, shaping raw materials according to eternal, perfect forms. This wasn't just a creation myth, it was philosophy's first systematic attempt to explain why the universe appears so finely tuned, so intentional. Now leap forward to Silicon Valley, where tech billionaires and physicists debate whether we're living in an artificial simulation, a universe coded by some advanced intelligence. Though separated by millennia, these two ideas share a spine-tingling premise: that reality, for all its apparent randomness, might be the product of deliberate design. The demiurge's workshop and the simulation hypothesis aren't just parallel thoughts, they're different dialects of the same profound question: is the universe an artifact? The demiurge's creative process eerily mirrors modern programming logic. Plato described this cosmic artisan imposing mathematical order on primordial flux, using geometric solids, tetrahedrons for fire, cubes for earth, as building blocks. Today's simulation theorists propose something strikingly similar, that our universe's laws might be algorithms, its particles pixel-like units rendered by some unfathomable computational process. The ancient Greeks lacked the language of quantum fields or binary code, but their intuition that reality runs on mathematical scaffolding was shockingly prescient. Even the demiurge's limitation working with imperfect materials finds its counterpart in glitches like quantum indeterminacy, which some interpret as evidence of our universe's source code approximating continuity. What's truly fascinating is how both systems account for imperfection. The demiurge's creation, though magnificent, wasn't flawless. Plato's world contained war, decay, and natural disasters. Simulation theory offers a chillingly similar explanation for suffering. It could be emergent complexity from base rules, or even intentional friction to make the simulation feel real. The Gnostic twist on the demiurge, that it might be a lesser, fallible god, resonates with Nick Bostrom's suggestion that ancestor simulations would likely be run by civilizations with limited resources, leading to corners cut in rendering distant galaxies or subatomic particles. Both traditions acknowledge that a crafted universe needn't be perfect, just internally consistent enough to sustain its inhabitants' belief in its reality. The parallels extend to their epistemological crises. Plato's allegory of the cave where prisoners mistake shadows for substance anticipates modern concerns about discerning simulated from base reality. Hindu cosmology's concept of Maya, the illusion obscuring true existence, mirrors the simulation argument's suggestion that our perceptions could be layers, deep interfaces masking underlying code. Even the demiurge's use of pre-existing forms, the Platonic ideals, finds a counterpart in the idea that our universe's physics might be copied or inherited from a parent reality. These aren't vague similarities, they're evidence that humanity has always sensed reality's potential artifice, long before computers provided a metaphor. This convergence raises a provocative possibility that the simulation hypothesis isn't a product of the digital age, but the latest expression of an ancient suspicion. When Neolithic builders aligned Stonehenge to solstices or Mayan astronomers tracked Venus cycles with uncanny precision, they weren't just observing nature, they were reverse engineering what they suspected was a designed system. Today's physicists searching for pixelation in cosmic rays or anomalies in quantum behavior are continuing that same investigative tradition. Whether through the demiurge's geometric forms or a programmer's algorithms, we keep circling the same unsettling revelation that the universe might not just be, but be made. And if that's true, the greatest discovery wouldn't be the designer's identity, but the awe-inspiring realization that we've been glimpsing their handiwork all along. Long before telescopes revealed the cosmic dance of planets, Pythagoras stood under the star-studded Greek sky and heard what others couldn't as celestial harmony. To him, the planets didn't just move, they sang, each orb tracing its path through the heavens with a distinct pitch, blending into a grand symphony he called the music of the spheres. This wasn't mere metaphor. The philosopher mathematician, famous for discovering the numerical ratios behind musical intervals, believed the universe itself was structured like a lyre, its vibrations dictating everything from the orbits of worlds to the beating of human hearts. Now, string theorists echo his vision with uncanny precision, proposing that the fundamental building blocks of reality aren't silent particles but tiny, vibrating strings, each oscillation producing the cosmic equivalent of a musical note. The universe, it seems, has always been a composition in progress, and myth and science are just beginning to listen to the same score. Pythagoras' revelation began with something deceptively simple, plucking a taut string. He noticed that dividing it into whole number ratios produced perfect harmonies, having it created an octave. A third produced a fifth, and so on. To his ears, these intervals weren't just pleasant sounds, they were glimpses of a hidden mathematical order governing existence. Fast forward to the 20th century, and string theory's equations reveal a strikingly similar principle: the difference between an electron and a quark. Just like the difference between a C and a G, it's all about vibrational frequency. The strings at reality's core don't just wiggle randomly, they resonate at precise harmonics, their oscillations determining whether they manifest as matter, light, or even gravity. The universe isn't just like music, it is music written in the language of vibration. What's astonishing is how these ancient and modern harmonies align. The Pythagorean scale was built on ratios, simple, whole number relationships between pitches. String theory's own notes emerge from mathematical symmetries, where the shape of hidden dimensions dictates possible vibrational modes. The Greeks imagined the spheres of Mercury, Venus, and Mars each humming at different frequencies, their combined tones forming a chord. Today's physics proposes that the quantum fields permeating space behave like an orchestra, with the Higgs field as the bass drone underlying the melody of particles. Even the concept of dissonance finds its counterpart in physics. When vibrational patterns clash, particles annihilate in bursts of energy, the cosmic equivalent of a cymbal crash. The parallels grow richer when examining silence. In Pythagorean mysticism, the outermost sphere, home to the fixed stars, was utterly silent, a perfect unity beyond sound. String theory's ground state mirrors this idea. The lowest possible vibration of a string isn't absence but potential, the quiet hum of the quantum vacuum from which all particles emerge. Hindu Nada Brahma teachings take this further, describing creation as the primal syllable, vibrating into infinite forms, just as a single string's harmonics generate the diversity of the quantum world. Both systems recognize that music isn't just about the notes you hear, but the spaces between them, the silent framework that makes harmony possible. Perhaps the most profound convergence lies in their treatment of the listener. Pythagoras didn't just study music, he initiated disciples into its mysteries, believing trained ears could perceive the cosmic symphony. Modern physics, too, requires listening through mathematics, interpreting the faint vibrational signatures of particles in colliders or the resonant patterns of gravitational waves. The Aboriginal songlines, where the land itself is said to hold ancient melodies, find an unexpected echo in the cosmic microwave background, the afterglow of the Big Bang, which physicists now analyze for harmonic peaks like musicians reading sheet music. Whether through sacred chant or spectral analysis, humanity keeps tuning into the same truth. The universe doesn't just play music, it is music, and we, whether we realize it or not, are its most attentive audience. From the obsidian mirrors of Aztec priests to the enchanted looking glass of European fairy tales, humanity has long been fascinated by surfaces that reveal more than they should. These weren't just tools for vanity or prophecy, they were prototypes for one of physics' most radical ideas, that our three-dimensional universe might be a holographic projection from a two-dimensional surface at the edge of reality. The ancient mystics who peered into polished stone seeking visions, and the physicists who calculate how information encodes on cosmic horizons are asking the same startling question: is depth itself an illusion? Take the Chinese legend of the Mirror of the Seven Marvels, said to reflect not just appearances, but the true nature of whoever gazed into it. This mirrors, quite literally, the holographic principles claim that all information about a volume of space is encoded on its boundary, like a reflection containing the full essence of the object it depicts. The Aztecs took this further. Their god Tezcatlipoca's smoking mirror didn't just show images, it revealed hidden truths and alternate realities, much like how a black hole's event horizon, a theoretical holographic surface, preserves information about everything that falls into it. These myths didn't just play with reflection, they intuited that surfaces can encode unfathomable depth when viewed through the right lens. Modern physics catches up to these ancient insights in astonishing ways. The mathematics of black holes suggest that all the information about objects swallowed by them isn't lost. It's smeared across their surfaces in Planck-scale pixels, like a cosmic mirror preserving every detail in scrambled form. This mirrors the Mayan concept of the black mirror, used by shamans to commune with ancestors whose memories were thought to reside in its polished surface. Both systems recognize that information isn't bound by volume, that what appears flat might hold entire worlds within its structure. The parallels grow even richer when examining distortion. Fairy tales warn that magic mirrors often lie, bending truths or showing only fragments. Similarly, the holographic principle suggests our three-dimensional experience is a kind of controlled hallucination, a useful approximation reconstructed from incomplete data. Just as Snow White's stepmother saw only what she desired in her mirror, our brains construct a seamless 3D reality from the universe's 2D information layer, filling gaps with assumptions. The Hindu concept of Maya, the illusion masking ultimate reality, takes this further, proposing that all sensory experience is a reflection of deeper patterns, like shadows cast by a cosmic magic lantern. Perhaps most profound is how these traditions handle interactivity. The Celtic legend of the Lady of the Lake presents a mirror-like surface that only yields Excalibur to the worthy, a metaphor for how holographic reality responds to observation. Quantum mechanics shows that particles only assume definite states when measured, as if the universe renders reality upon interaction, like a mirror that only reflects when someone looks. The Japanese Yota no Kagami, one of the imperial regalia, was said to reflect not images but the viewer's soul, echoing how modern physics suggests consciousness itself might play a role in collapsing quantum probabilities into tangible experience. This convergence of myth and theoretical physics invites us to reconsider what mirrors truly represent. When a Renaissance magus scribe answers in a crystal ball or a physicist calculates entropy on a black hole's event horizon, they're engaging with the same fundamental mystery, that reality's most solid-seeming aspects might be the most illusory. The next time you catch your reflection, consider this. You might not be looking at a flat image, but a fragment of a cosmic code, one that writes depth into existence through nothing more than vibrating strings of information. The ancient Hindu texts speak of the Kshaira Sagara, an infinite ocean of milk stretching beyond time and space, its surface churning with primordial energy. This wasn't just poetic imagery, it was a startlingly accurate metaphor for what quantum physicists now call the quantum foam, the seething foundation of spacetime itself. Picture the surface of this cosmic milk ocean, where waves don't just ripple, they birth and dissolve entire universes with each surge, much like the fleeting particles that blink in and out of existence within the quantum vacuum. The resemblance isn't superficial, it's a profound alignment of myth and science, both describing reality's turbulent undercurrent where nothing is ever truly still. Dive deeper into the metaphor, and the parallels grow even more striking. The Kshaira Sagara's most famous moment in Hindu lore is the Samudra Manthan, the churning of the ocean by gods and demons using the serpent Vasuki as a rope. As they pulled, the ocean yielded both nectar of immortality and deadly poison, a duality mirrored in quantum foam's own contradictions. At scales a billion times smaller than an atom, spacetime isn't smooth. It froths with virtual particles, electron-positron pairs that borrow energy from the vacuum only to annihilate moments later. Like the nectar and poison, these particles represent creation and destruction in the same breath, a ceaseless dance where existence borrows against the void. What's truly remarkable is how both systems describe scale. The Puranas depict the Kshaira Sagara as fractal, its waves containing smaller waves ad infinitum. Modern physics reveals quantum foam operates similarly. The closer you zoom into spacetime, the more turbulent it becomes, with tiny bubbles of warped geometry forming and dissolving in Planck-length intervals. The Hindu texts even speak of the ocean's depths hiding unimaginable treasures, echoing how the quantum vacuum isn't empty but brimming with zero-point energy, a potential so vast it could power entire universes if harnessed. The most profound connection lies in their shared ambiguity. The Kshaira Sagara is often described as neither liquid nor solid, but a substance beyond conventional states, much like quantum foam defies classical categories, blurring the line between particle and wave, matter and energy. When Vishnu reclines on the serpent Ananta in this ocean, he isn't floating passively. He's depicted as both observer and participant, sustaining the churning while dreaming creation into being. This mirrors the quantum physicist's dilemma, that observing the foam's activity inherently alters it, making the universe's foundational layer as elusive as it is omnipresent. This convergence of myth and science invites us to reconsider what we call nothing. The quantum vacuum isn't a static backdrop, it's a dynamic medium, more like the Kshatriya Sagara's restless tides than the dead void of classical physics. When a Hindu devotee pours milk into the Ganges as an offering, or when a physicist calculates the Casimir effect where two metal plates in a vacuum inexplicably attract due to quantum fluctuations, they're engaging with the same fundamental truth, that the universe's calm surface hides infinite depth, and what appears as silence is actually a symphony of ceaseless creation. The phoenix's fiery demise isn't an end. It's a transformation, a surrender to forces unseen before rising renewed. Ancient Egyptians depicted the Bennu bird vanishing in flames only to emerge from its own ashes, while Chinese legends tell of the Fenghuang dissolving into golden light before reforming. These stories capture something modern astrophysics confirms daily, that destruction often conceals creation's blueprint. Nowhere is this more evident than with dark matter, the invisible cosmic ash from which galaxies sculpt themselves, an unseen force as essential to cosmic rebirth as the phoenix's flames are to its renewal. Consider the phoenix's ashes not just residue, but the fertile medium for its return. In Greco-Roman lore, the newborn phoenix gathers these ashes into an egg of myrrh, carrying the essence of its former self into the next cycle. Dark matter operates similarly. Though it emits no light, its gravitational pull molds ordinary matter like stellar gas and dust into galaxies, guiding the birth of stars just as the ashes guide the phoenix's revival. The resemblance is uncanny. Both are invisible architects, one shaping life from its own remnants, the other shaping galaxies from primordial chaos. The parallels grow deeper when examining structure. The phoenix's rebirth isn't random. It follows an ancient cyclical pattern encoded in its very DNA. Dark matter, too, arranges itself into intricate cosmic webs, vast filaments stretching across the universe that funnel gas into galaxy clusters with almost algorithmic precision. Simulations of dark matter's distribution reveal fractal-like branching, eerily reminiscent of the phoenix's feather patterns in medieval bestiaries. Both systems suggest that what appears chaotic weather flames or the early universe's particle soup obeys a hidden order, a template written into the fabric of existence itself. What's truly astonishing is how both concepts handle agency. The phoenix doesn't just passively burn. Its combustion is an active ritual, a voluntary surrender to transformation. Dark matter, too, isn't a static scaffold. It dynamically interacts with visible matter through gravity, its invisible tendrils pulling stars into spiral arms and guiding galaxies into clusters. The Aztec Zoocotl, a fire serpent linked to rebirth, was said to knit the sky together as it moved, a poetic parallel to how dark matter's gravitational stitching binds the cosmos. Both forces operate behind the scenes, their full influence only revealed through their effects on the visible world. Perhaps the most profound connection lies in their necessity. Without ashes, the phoenix couldn't rise anew. Without dark matter, galaxies would fly apart, their stars scattered like embers in the wind. The Mayan resurrection god Hun-Hunahpu's bones sewn in the earth became the first maize, just as dark matter's gravitational wells planted the seeds for cosmic structure. Modern telescopes mapping dark matter through gravitational lensing, where its mass bends light from distant galaxies, are essentially tracing the outlines of these cosmic ashes, revealing the silhouette of a process ancient myths described millennia ago. This interplay of myth and astrophysics invites a radical rethinking of destruction's role. When a medieval alchemist studied the phoenix's cycle or a physicist models dark matter's influence, they're exploring the same fundamental truth, that what seems like endings are often the invisible hands of creation. The universe, it seems, has always known how to rebuild from the unseen, whether through the smoldering remnants of a mythical bird or the ghostly gravity of matter we're only beginning to understand. Across countless traditions, light isn't merely illumination, it's divinity made manifest. The ancient Egyptians worshipped Ra, whose solar bark carried the sun's radiance as both life-giver and cosmic judge. Hindu scriptures describe the god Surya radiating not just warmth, but wisdom itself, his rays piercing ignorance like arrows of clarity. Even the biblical Genesis begins with light's separation from darkness before the creation of sun or stars, suggesting something far more profound than mere photons. Fast forward to quantum electrodynamics, and light's role as mediator of the electromagnetic force reveals an uncanny parallel. These traditions weren't just poeticizing sunlight. They were intuiting light's role as the universe's fundamental messenger, the thread stitching reality together at its core. Consider how these myths describe light's origin. The Egyptian Heliopolitan creation myth tells of Autumn emerging from none, the primordial waters, and radiating light simply by opening his eyes, an act mirroring how photons spontaneously emerge from quantum vacuum fluctuations. Zoroastrianism's Ahura Mazda is depicted as pure, uncreated light battling darkness, a duality echoed in modern physics' wave-particle paradox. Even the Kabbalistic concept of Ein Sof, or the infinite light preceding creation, finds resonance in the cosmic microwave background, the afterglow of the Big Bang that still permeates every cubic centimeter of space. These traditions didn't just venerate light's practical benefits, they recognized its ontological primacy, how it dances at the boundary between existence and potential. Modern physics amplifies these ancient insights with mathematical precision. Photons, the quantum particles of light, are unique in the Standard Model. They have no mass, no electric charge, and travel at the universe's speed limit, making them ideal cosmic couriers. Just as Hermes carried messages between Greek gods and mortals, photons mediate electromagnetic interactions across vast distances instantaneously. The Hindu Gayatri mantra, which calls upon the sun to illuminate our intellect, takes on new meaning when considering how photosynthesis, driven by photons, literally powers the neural activity behind human thought. Light doesn't just enable vision, it facilitates the very interactions that make complex chemistry, and thus consciousness, possible. The mystical properties ascribed to light mirror quantum behaviors in startling ways. Sufi poets describe light as both particle-like nur and wave-like fade, presaging wave-particle duality by centuries. The Buddhist rainbow body phenomenon, where enlightened beings allegedly dissolve into light upon death, parallels how high-energy photons can materialize into particle-antiparticle pairs under the right conditions. Even the halos encircling saints in Christian iconography resemble the photon spheres predicted around black holes, regions where light orbits endlessly, trapped between gravity's pull and light's innate velocity. These aren't arbitrary artistic choices, they're intuitive grasps of light's liminal nature, how it exists at the threshold between the tangible and the transcendent. Perhaps most profound is how both systems handle light's transformative power. The Eleusinian mysteries of ancient Greece used controlled light exposure in underground chambers to induce visionary states, a practice modern science might explain as photic stimulation altering brainwave patterns. The Vedic practice of Surya Namaskar, sun salutations, wasn't just exercise. It synchronized the body with sunlight's circadian rhythms long before we understood melatonin regulation. Even the Jewish menorah's 7 flames encoded principles of spectral analysis, with each branch potentially representing a color in visible light's dispersion. These traditions treated light not as passive illumination, but as an active participant in shaping reality, a perspective quantum physics now confirms, where observation by light fundamentally alters the observed. This convergence of mysticism and physics invites us to see light anew, not just as a tool or symbol, but as the universe's original language. When a medieval stained glass artist positioned rose windows to catch the solstice sun, or when a physicist measures entanglement through photon polarization, they're engaging with the same essential mystery. That light is both messenger and message, the medium through which existence communicates with itself. Whether through prayer or prism, humanity keeps returning to this radiant truth, that to understand light is to glimpse the very architecture of creation. In the sacred texts of Hinduism, the gods don't just rule the cosmos, they play with it. The Rig Veda describes a cosmic dice game where deities wager with the fabric of reality itself, their throws dictating the rise and fall of ages. Fast forward to the 20th century, and Einstein famously resisted quantum mechanics' inherent randomness by declaring, "God does not play dice with the universe." The irony is breathtaking. Ancient myths embraced chance as a divine mechanism, while modern physics revealed it as a fundamental law. Both narratives, separated by millennia, converge on the same unsettling truth: that uncertainty isn't a flaw in the universe's design, but the very engine of its creativity. The Hindu concept of Leela, divine play, paints existence as a game where randomness and rules intertwine. Shiva's dance creates and destroys worlds with every step, while the goddess Kali's unpredictability mirrors quantum fluctuations' capricious nature. These aren't just metaphors for chaos, they're sophisticated models of probabilistic reality. The gods' dice, carved from thunderbolt bones in the Mahabharata, land in ways even they can't always foresee, echoing how subatomic particles exist in superpositions until measured, their outcomes governed by probability waves rather than deterministic paths. The ancients didn't just accept uncertainty, they sacralized it, recognizing that without chance, the universe would be a static, lifeless machine. Quantum mechanics amplifies this insight with mathematical rigor. Heisenberg's uncertainty principle, which states we can't simultaneously know a particle's position and momentum, mirrors the Hindu concept of Maya, the illusion that reality is fixed or fully knowable. Schrödinger's cat, simultaneously alive and dead in its box, finds its mythological counterpart in the god Vishnu's dream state, where all possible universes exist in potential until observed. Even the many worlds interpretation, where every quantum decision spawns alternate timelines, resonates with the Puranic description of infinite branching realities sprouting from Brahma's lotus navel. The myths didn't predict quantum theory's equations, but they anticipated its philosophical implications that probability isn't a limitation of human knowledge, but a structural feature of existence. What's truly revelatory is how both systems handle agency within randomness. The Hindu dice game isn't pure chaos, it unfolds within Dharma's cosmic order, just as quantum probabilities obey strict statistical laws. The Buddha's teachings on dependent origination, where randomness arises from infinite causes, parallel quantum decoherence, where probabilities crystallize into definite outcomes through environmental interaction. Even Einstein's skepticism about spooky action at a distance mirrors Arjuna's despair in the Bhagavad Gita when faced with a universe that seems capricious until Krishna reveals its deeper patterns. Both traditions suggest that what appears random from one perspective reveals meaning when viewed through a wider lens. This convergence invites us to reconsider chance's role in creation. When a Vedic priest casts marked sticks for divination or a physicist calculates wave function collapse, they're engaging with the same fundamental mystery, that the universe thrives on the tension between possibility and actuality. The next time you roll dice in a board game, consider that you're not just playing against odds, but participating in an ancient cosmic ritual, one where uncertainty isn't the absence of order, but the space where new realities are born. Friedrich Nietzsche's haunting proposition, that time loops eternally, forcing us to relive every joy and sorrow endlessly, wasn't just a philosophical thought experiment. It was an eerie foreshadowing of string theory's most radical cosmological model, the cyclic universe. Both visions, one born in the fevered notebooks of a 19th-century philosopher and the other in the chalkboard equations of 21st-century physicists, converge on the same spine-tingling possibility, that existence isn't a linear march from birth to heat-death, but an infinite symphony of recurring verses, each big bang the opening chord of a cosmic refrain we've heard before. Nietzsche's eternal return wasn't merely about repetition, it was a crucible for meaning. In Thus Spoke Zarathustra, he imagined a demon whispering that every pain and triumph would recur in identical sequence, demanding we live in a way that makes this inevitability exhilarating rather than terrifying. String theory's cyclic model, developed by physicists like Paul Steinhardt and Neil Turok, mirrors this existential weight. Their mathematics suggest that colliding brains, multidimensional membranes floating in higher dimensional space, could trigger endless cycles of cosmic expansion and contraction. Each collision births a new universe with nearly identical physical constants, preserving subtle traces of prior cycles like echoes in a cavern. The resemblance is uncanny. Both systems propose that time's arrow might curve back on itself, not as perfect replication, but as a spiral where each iteration carries forward faint imprints of what came before. What's truly astonishing is how both frameworks handle entropy, the universe's inevitable slide toward disorder. Nietzsche's return required confronting the heaviest weight, the idea that even decay and chaos would repeat ad infinitum. The cyclic model tackles this head-on through dark energy, which not only accelerates expansion but may reset entropy during each big crunch. Just as Zarathustra's Overman embraces eternal recurrence as life-affirming, the cyclic universe uses entropy's crescendo as the prelude to renewal, a cosmic phoenix rising from the ashes of its own dissipation. The Hindu concept of pralaya, periodic dissolutions preceding new creations, bridges these ideas. Destruction isn't an end, but the necessary ground for rebirth. The parallels grow richer when examining memory across cycles. Nietzsche hinted at eternal recurrences, psychological paradox. How could one embrace recurrence without remembering past iterations? String theory's cyclic model suggests a resolution. Quantum fluctuations imprinted in the cosmic microwave background might carry statistical fingerprints of prior universes, like faint scars on spacetime. Aboriginal songlines, which encode ancestral memories in landscape features, offer a poetic counterpart, knowledge preserved not in linear time, but in the very fabric of reality. Whether through philosophy or physics, the same question persists. Can a universe forget itself entirely, or are there always traces whispering, "This has happened before"? Perhaps the most profound alignment lies in their treatment of agency. Nietzsche's eternal return was ultimately a call to action, live so fervently that you'd welcome infinite repetitions. The cyclic universe, too, invites participation. Some models propose that advanced civilizations could influence the next cycle's initial conditions, encoding information in black hole singularities or gravitational waves. The Buddhist Bardo state between death and rebirth, where consciousness actively shapes its next incarnation, mirrors this potential for intentionality across cosmic cycles. Both visions reject passive fatalism, suggesting that even in an endlessly recurring cosmos, meaning emerges from how we navigate the wheel. This convergence of philosophy and theoretical physics reveals something startling about human thought. When Nietzsche's Zarathustra danced under the stars proclaiming, "All things recur eternally," or when string theorists calculate colliding brains in 11-dimensional space, they're wrestling with the same existential vertigo. The possibility that beginnings and endings are illusions, that time is a Möbius strip with no true starting point. The cyclic universe doesn't just validate ancient intuitions about eternal return. It transforms them into testable science, where the echoes of past universes might one day be detected in the faint afterglow of our own. Whether through parable or partial differential equations, humanity keeps circling the same revelation. The cosmos may not be a one-act drama, but a play performed endlessly, each iteration subtly altered by the choices of its players. A Tibetan monk crouches on the temple floor, slowly releasing colored sand through a metal funnel called a chakpor. Grain by grain, over days or even weeks, an intricate cosmic diagram takes shape, a mandala radiating outward in perfect geometric patterns, only to be ritually destroyed upon completion. This ancient practice might seem worlds apart from a physicist's chalkboard scribbled with equations about curled-up dimensions. Yet zoom in on those equations, and you'll find shapes called Calabi-Yau manifolds, six-dimensional forms resembling nothing so much as those sacred sand paintings, their folds and curves determining how strings vibrate to create reality itself. The mandala isn't just art, it's a blueprint of the universe's hidden architecture, drawn in silence centuries before microscopes could glimpse the quantum weave. Consider the mandala's structure. At its heart sits the bindu, a single point representing both the universe's origin and the meditator's consciousness. Radiating outward are concentric circles, squares, and lotus petals, each layer symbolizing a stage of enlightenment or a realm of existence. Now examine a Calabi-Yau shape through string theory's lens. Its compactified dimensions curl inward at scales 1 billion times smaller than an atom, their topology dictating how strings oscillate to produce particles. The resemblance is uncanny. Both systems use nested, symmetrical geometries to bridge the infinite and the infinitesimal. When a monk visualizes ascending through the mandala's layers during meditation, they're traversing dimensions as surely as a string vibrating through a Calabi-Yau's folds. The parallels deepen when examining transformation. Mandalas aren't static, they're tools for dissolution and rebirth. Practitioners mentally deconstruct them layer by layer, returning to the central void before reconstructing the cosmos anew. This mirrors how Calabi-Yau shapes facilitate symmetry breaking in string theory. As the early universe cooled, these curled dimensions deconstructed from perfect symmetry, allowing forces like electromagnetism and the weak nuclear force to differentiate. The mandala's ritual destruction mirrors the cosmic transition from unity to diversity, a process encoded in both spiritual practice and the universe's very fabric. What's truly revelatory is how both systems encode information. Tibetan mandalas often feature the Palace of the Five Buddhas, each deity representing a color, element, and cardinal direction, a symbolic periodic table of existence. Similarly, Calabi-Yau manifolds store data about particle properties in their topology. The number of holes in the shape determines how many generations of quarks exist, while its curvature influences the strength of fundamental forces. The Jain cosmological maps take this further, depicting the universe as a giant human figure, the Lokapurusha, whose body parts correlate to cosmic regions, a precursor to string theory's holographic principle, where information on a boundary encodes a higher dimensional reality. Modern physics catches up to these ancient insights in startling ways. When researchers simulate Calabi-Yau shapes, they generate three-dimensional cross-sections that look unsettlingly like mandala motifs, interlocking triangles, flower-like petals, and labyrinthine pathways. The Hindu Shri Yantra, composed of 9 interlocking triangles radiating from a central point, mirrors the way string theorists visualize intersecting brains in higher dimensional space. Even the mandala's traditional materials, colored sands representing Earth's elements, find a counterpart in string theory's landscape problem, where each possible Calabi-Yau configuration corresponds to a universe with different physical constants, like grains of sand in a cosmic desert. This convergence invites a radical rethinking of sacred art, when a monk meticulously places each sand grain, or when a physicist calculates the Euler characteristic of a 6-dimensional shape. They're engaging in the same essential act, mapping the invisible scaffolding of reality. The next time you see a mandala's hypnotic symmetry, consider that you might be looking at more than a spiritual symbol. You could be glimpsing the deep geometry that strings the cosmos together, a pattern written into existence long before humans put pencil to paper or sand to temple floor. The ancient Hindus called it prana, the breath of the cosmos, the invisible current that animates all life. The Stoics named it pneuma, the fiery wind weaving through the void, shaping stars and souls alike. These weren't just poetic metaphors for air. They were intuitions of something far stranger, the seething, invisible energy that modern physics calls the quantum vacuum. What these traditions described as cosmic breath, we now recognize as the universe's hidden pulse, an omnipresent energy field so fundamental that without it, reality itself would dissolve into nothingness. Picture the vacuum of space not as an empty void, but as a living medium crackling with potential. Quantum physics reveals that even at absolute zero, when all motion should cease, space still trembles with activity. Virtual particles flicker in and out of existence, borrowing energy from nowhere, existing just long enough to stitch the fabric of reality together before vanishing again. This isn't abstract theory, it's measurable. The Casimir effect shows how two metal plates in a vacuum inexplicably pull toward each other, pushed by the restless energy of the quantum foam between them. The Stoics imagined pneuma as a tensile force, stretching and compressing like a divine lung, an image eerily mirrored in the vacuum's fluctuations, where space itself expands and contracts at the smallest scales. The parallels grow even more profound when examining how these ancient frameworks describe vitality. Ayurvedic texts detail prana flowing through nadi's subtle channels analogous to the nervous system, regulating everything from heartbeat to thought. Similarly, vacuum energy isn't passive background noise, it actively shapes the universe. Without it, electrons wouldn't maintain their orbits, atoms would fly apart, and the delicate balance allowing chemistry, and thus life would collapse. The Hindu concept of pranayama breath control mirrors this precisely. By consciously regulating breath, practitioners tap into the same foundational rhythm that animates galaxies. Even the Taoist Kai, often visualized as swirling vortices, finds its counterpart in quantum field theories, zero-point energy vortices, where electromagnetic fields twist into self-sustaining loops. What's truly astonishing is how both systems handle scale. The Upanishads describe prana as simultaneously cosmic and microscopic, sustaining both the flight of eagles and the division of cells. Vacuum energy operates identically. It's equally present in the vast emptiness between galaxies and the subatomic gaps between quarks. The Stoics took this further, claiming pneuma thickened into matter or rarefied into soul depending on its tension, a concept shockingly close to modern field theories where particle mass emerges from interactions with the Higgs field. Whether through meditation or mathematics, humanity has always sensed that the boundary between empty space and living matter is far blurrier than it appears. Perhaps the most striking convergence lies in their creative power. Vedic hymns describe prana as the force that knits together the universe, much like vacuum fluctuations are now thought to have seeded cosmic structure in the early universe. The Gnostic Sophia, whose breath fashioned the material world from chaos, mirrors how quantum foam's irregularities may have sparked galaxy formation. Even the Mayan wind god Huracan, whose name means one-legged to signify dynamic imbalance, reflects vacuum energy's asymmetry, its slight excess over gravity that's accelerating the universe's expansion. These traditions didn't just personify natural forces, they encoded a radical insight that what we call empty space is actually the womb of creation. This interplay of myth and physics invites us to reconsider what animates existence. When a yogi inhales deeply, drawing prana into their being, or when a physicist calculates the Lamb shift, where vacuum energy subtly alters an electron's orbit, they're engaging with the same fundamental mystery. The cosmic breath isn't just a metaphor, it's the universe's most essential rhythm, the silent hum beneath all sound, the invisible hand that turns potential into being. Whether through sacred chant or Schrödinger's equation, we keep rediscovering the same truth: emptiness is alive, and the void has always been breathing. Centuries before Einstein dreamed of a unified field theory, alchemists toiled in candlelit workshops pursuing their own version of ultimate knowledge, the legendary Philosopher's Stone. This wasn't just about turning lead into gold. It was about uncovering nature's fundamental language, a substance so pure it could dissolve all matter into its primordial essence. The parallels between their quest and modern physics' search for a theory of everything aren't just poetic. They reveal how humanity's deepest intellectual cravings transcend time and methodology. Both traditions chase the same elusive prize, a single, elegant framework that explains the bewildering diversity of existence. Take the alchemist's prima materia, the formless base substance believed to underlie all creation. Medieval texts describe it as both everything and nothing, a paradox mirroring the quantum vacuum's zero-point energy, where particles flicker in and out of apparent emptiness. The Emerald Tablet's famous dictum, "as above, so below," finds its scientific counterpart in scale invariance, the principle that patterns repeat from quantum foam to galactic superclusters. When alchemists wrote of solve et coagula, dissolve and coagulate, they might as well have been describing symmetry breaking in the early universe, where a unified force fractured into the four we know today. These weren't primitive guesses, they were intuitive leaps toward a truth we're still unraveling with particle colliders and string theory. The Philosopher's Stone's most mystical property, its ability to confer immortality, resonates with cosmology's own holy grail, a theory so complete it could predict every cosmic phenomenon from quark interactions to galaxy formation. Just as the stone symbolized perfection emerging from chaos, modern unification theories seek mathematical harmony beneath nature's apparent complexity. The alchemical Ouroboros, the serpent eating its tail, mirrors the self-contained elegance physicists crave, a set of equations where gravity emerges from quantum mechanics as naturally as a circle closes upon itself. Even the stone's legendary red color hints at today's redshift in an expanding universe, where deeper truths reveal themselves through spectral signatures. What's truly revelatory is how both traditions handle failure. Alchemists encrypted their texts in symbolic imagery, not just to conceal, but to acknowledge the ineffable, that some truths resist literal expression. Modern physics faces its own communicative crisis: how to convey 11-dimensional string theory or quantum entanglement without analogies that inevitably distort. The alchemists' failed experiments and the physicists' theory of everything candidates that keep multiplying rather than unifying both testify to the same humbling reality, that ultimate knowledge may be a horizon, always receding as we advance. This convergence invites us to see alchemy not as pseudoscience, but as the philosophical ancestor of unification physics. When a Renaissance adept stirred mercury in a crucible or a CERN researcher analyzes proton collisions, they're performing the same essential act, probing the boundary between the tangible and the transcendent. The stone wasn't just an object, it was a metaphor for the human mind's relentless drive to find coherence in chaos, a drive that continues to shape our grandest theories about the cosmos. Whether through alembic or atom smasher, we're all chasing the same shimmering revelation, that beneath reality's dazzling diversity lies a unity so profound, it might just deserve to be called sacred. The great looms of destiny never sit idle, whether in the shadowed halls of Norse mythology or the equations of quantum field theory. The Norns, those three sisters of fate from Scandinavian legend, spin and cut the threads of existence at the foot of Yggdrasil, while the Greek Moirai measure and weave the lifelines of gods and mortals alike. These aren't just stories about weaving, they're profound metaphors for how reality itself might be constructed. Fast forward to modern physics, and we find quantum fields, invisible, omnipresent matrices that stretch across the universe, vibrating into temporary existence as particles, much like threads pulled briefly into focus before dissolving back into the cosmic tapestry. Think of the Norns' loom, where each thread represents a life or event, intersecting with countless others to form an unbreakable web of cause and effect. Quantum fields operate similarly. The electromagnetic field, for instance, hums with potential until a vibration manifests as a photon, a fleeting stitch in the fabric of space-time. The Higgs field is even more like the Norns' threads, granting mass to particles as they move through it, much like how the Norns' weaving determines the weight and texture of each destiny. The resemblance goes beyond surface-level poetry. Both systems describe a universe where nothing exists in isolation, where every particle or fate emerges from its relationship to the whole. What's truly fascinating is how these myths anticipated quantum entanglement. The Moirai don't just weave individual threads, they interlace them, ensuring that a tug on one lifeline reverberates through the entire tapestry. Quantum physics reveals the same interconnectedness. When two particles become entangled, measuring one instantly affects its partner, no matter the distance. The Norse called this weird, the web of destiny where every action ripples outward. Modern experiments with Bell's theorem confirm that these connections aren't just metaphorical, they're mathematically inevitable, woven into reality's deepest layers. Parallels extend to creation and destruction. The Norns' scissors, poised to sever a thread at life's end, mirror the annihilation of particle-antiparticle pairs, their energy dissolving back into the quantum vacuum. The Greek Clotho spins new threads, much like quantum fluctuations spontaneously generate particles from empty space. Even the cyclical nature of the loom, where finished cloth is removed so weaving can begin anew, finds its counterpart in the endless dance of virtual particles blinking in and out of existence. These myths didn't just guess at nature's dynamism, they encoded the principle that reality is a process, not a static object. Perhaps most striking is how both traditions handle uncertainty. The Norns weave fate, yet Norse sagas are full of heroes challenging their destined ends. Similarly, quantum fields generate probabilities rather than certainties. Wave functions that collapse into definite states only upon observation. The Moirai's threads may set the pattern, but as Penelope demonstrated in the Odyssey, even woven destiny can be unraveled and reworked. This tension between determinism and free will plays out in quantum mechanics as the observer effect, where measurement itself shapes the outcome. The ancients may not have had wave functions, but they understood that fate, like a quantum state, exists in superposition until acted upon. This isn't just a poetic coincidence, it's evidence of how deeply humanity has always sensed reality's woven nature. When a Viking skald sang of the Norns carving runes into Yggdrasil's roots, or when a physicist today diagrams Feynman's path integrals showing particles exploring every possible route through spacetime's loom, they're describing the same fundamental truth. The universe doesn't just contain connections, it is connection, a living tapestry where every thread, whether of myth or mathematics, holds the rest in place. To pull one is to tremble the whole, and in that vibration we hear the hum of something ancient, something the weavers have always known. The initiate stands at the cave's mouth, torch trembling in hand, just as the physicist pores over equations at dawn, coffee gone cold. From the Eleusinian mysteries to modern quantum labs, the seeker's journey follows the same arc, a descent into darkness, confrontation with the unimaginable, and the fragile hope of emerging transformed. Ancient myths prepared their heroes for this ordeal with symbolic trials, slaying dragons, solving riddles, enduring isolation. While today's scientists face their own gauntlet of peer review, particle colliders, and the terrifying possibility that the universe might not conform to human logic. What unites them isn't just the quest for knowledge, but the humbling recognition that every answer unravels three new questions. Consider the Greek hero Orpheus descending into Hades, his lyre's music the only tool to navigate realms where ordinary laws dissolve. String theorists wield mathematics with similar daring, their equations like harmonic bridges across dimensions no telescope will ever see. The Maya depicted their maze god's journey through the underworld as a series of tests requiring both brute calculation and poetic intuition, mirroring how theoretical physics demands left-brain rigor and right-brain creativity in equal measure. Even the Buddha's night under the Bodhi tree, resisting Mara's temptations of easy answers, finds its counterpart in the scientist's struggle against confirmation bias. Enlightenment, whether spiritual or scientific, rarely comes to those who demand simplicity. The trials escalate when the seeker approaches the threshold. The Egyptian Book of the Dead warned of 42 judges weighing the heart against Mat's feather, a metaphor for academia's grueling defenses where theories stand trial before skeptical peers. The Aboriginal walkabout sends young initiates into the desert with nothing but ancestral songs to guide them, much like junior physicists armed only with Occam's razor and a handful of partial differential equations. Failure isn't just possible, it's inevitable. The Norse god Odin hung 9 nights on Yggdrasil, pierced by his own spear, to win the runes, an apt symbol for how paradigm shifts require intellectual suffering, the surrender of cherished assumptions to grasp deeper truths. What's truly revelatory is how both traditions handle revelation's aftermath. The shaman returning from a vision quest isn't handed a diploma. They're burdened with the responsibility to translate cosmic insights into practical wisdom for their community. Similarly, Einstein's breakthroughs on relativity didn't end with E equals mc squared. They demanded years of refinement, communication, and defense against detractors. The Cherokee Booger dance, where initiates re-enter society wearing masks to symbolize their transformed perspective, mirrors how scientists must relearn ordinary reality after glimpsing quantum entanglement or curled dimensions. Knowledge isn't a trophy to possess, but a lens that permanently alters how one sees the world. This final parallel offers no tidy conclusion because the seeker's journey never truly ends. The Buddhist parable of the mustard seed teaches that grief's weight is universal. Just as string theory's landscape problem suggests our universe's constants might be one accidental configuration among countless others. Both revelations dissolve arrogance, replacing it with either despair or a profound call to keep searching. The myths gave their heroes talismans, Theseus' thread, Aeneas' golden bow, to navigate uncertainty. Today's scientists clutch their own charms, the scientific method, the principle of falsifiability, the stubborn faith that patterns exist beneath the noise. Whether carved on temple walls or whiteboards, the message remains. The universe reveals itself not to the passive, but to those willing to lose themselves in the labyrinth. From the cosmic egg to vibrating strings, these 42 parallels reveal a profound dialogue between ancient wisdom and modern science, not as competing narratives, but as different expressions of the same eternal curiosity. Consider this: when the Hindu Rigveda described the golden Brahmanda egg floating in the void, or when Norse myth spoke of Yggdrasil's roots drinking from hidden wells, they weren't just telling stories. They were mapping the cosmos with the best tools they had: metaphor, observation, and the human mind's uncanny ability to recognize patterns. Today, we peer through telescopes and particle colliders, yet we're still asking the same fundamental questions. Where did everything come from? How does it hold together? And what strange music hums beneath the surface of reality? What's truly astonishing isn't just the accuracy of these ancient intuitions, but their resilience. The Mayan world tree, with its roots in the underworld and branches in the heavens, mirrors the cosmic web's dark matter filaments connecting galaxies across unimaginable distances. The Egyptian serpent Apep, chaos incarnate, slithers through their texts much like quantum fluctuations ripple through the vacuum of space. These aren't lucky guesses, they're evidence of humanity's deep-seated drive to make sense of the universe, whether by campfire or in a CERN control room. The mediums have changed, but the mission remains: to decode the grand design. This intersection of myth and science invites us to reconsider what knowledge really means. For millennia, shamans and storytellers passed down creation tales that modern equations now echo, not because they had telescopes, but because they paid attention. They watched how a river's eddies mirrored the spiral of stars, how a spider's web trembled like the threads of fate. Indigenous Australians still sing the land into being through songlines, just as string theorists describe reality as a symphony of vibrating strands. Different methods, same revelation. The universe is alive with connection. So where do we go from here? The answer lies in keeping both eyes open, one on the wisdom of the past, the other on the discoveries of the future. When physicists grapple with dark matter's mysteries, they might find clues in the Cherokee legend of the Octina, a serpent whose scales reflect every possible path. When astronomers map black holes, they could learn from the Tibetan Bardo Therdol, which describes the singularity of consciousness between lives. The next breakthrough might not come from a lab alone, but from a scholar who pauses to consider, what if this equation is just another way of telling an old story? As we stand on the shoulders of both giants and ancestors, let's keep exploring with humility and wonder. The universe has always been whispering its secrets, sometimes in the language of mathematics, sometimes in the cadence of a myth. Your thoughts might be the missing piece. Which parallel astonished you the most? Have you encountered other myths that mirror modern science? Drop your revelations in the comments, and let's keep this conversation spinning like a quantum in a cyclotron. For more journeys where the past and future collide, hit subscribe, because the greatest discoveries often begin with a once upon